You like me, Richard, huh? Looking funny with our headset, huh? All right. Ready? Okay. So very good morning, everyone, and thank you for coming to this session. So we're going to address today robotics and AI. As you know, Esri is not in the business of robotics per se, but the imagery that are collected from drones, from satellite imagery, or from any cameras on an airplane or any other devices, are of course processed with our tech by multiple customers around the world. And we'd like to share with you how they are doing that, many use cases that we have. AI is something you've heard during the plenary over and over again. Our also partners in the exhibit are proposing a lot of AI solutions they have. And today we'll share with you the core technologies and capabilities within ArcGIS so that as part of your various initiatives in your organization, you can see how you can leverage the technology that you have acquired and invested in. So we have like an hour in front of us. We have quite a lot of content, Manoj and I, to share with you, but we also want to make sure that you can ask us some questions. So please park them for the last 10 minutes, right? Last 10 minutes we will take the questions. Okay, so let's just go and proceed. So I will be with my colleague Manoj today, who's from Esri, Saudi Arabia. He's the Director of Business Development in the Kingdom of Saudi. And myself, I'm Christelle. I'm based both in Riyadh and in the UAE, and I do a business development for the infrastructure sector. In the older days, I used to focus primarily on utilities and telecom. Now, as we see more and more infrastructure being deployed in the GCC countries, like rail, ports, airports, seaports, all of those infrastructures. So I'm also focusing on that alongside with some of my colleagues, like Gaith. We'll have some sessions later on today. So please don't miss that one. It's an important one. Okay, next. Yeah, so this one, maybe say a few words.
We request you all that at the end of the session, kindly provide your feedback. There is a QR code. You can download the application and then provide the feedback.
Yeah, and to be honest, anything that is good, we're not really very much interested. Just tell us what doesn't work for you. And sometimes it might sound some details, but we want to make sure your experience today, of course, this week, of course, but also next year when you come back is always a great experience. Yes, so in terms of agenda, like 3 main topics we're going to cover, like I mentioned early on, imagery and robotics, and then the second part will be more on Geo-AI and generative AI. We give you some examples of what some customers are doing and also some prototypes that we've done. And we will finalize with some ArcGIS AI framework capabilities, more on the AI agents as well, that Esri is developing heavily at the moment on. Okay. So I will sit just to kind of control a little bit the thing here. So let's talk about robotics and AI. So in the context of robotics, here I'm referring to anything that is autonomous sensing platforms. Okay, so that's, like I mentioned, aerial systems, drones, satellites. And the idea is that continuously there is capture of high volume of imagery and reality data. And that's really the key part, right? How do you manage this big amount of data? It's not just I capture one imagery and I deal with one imagery, but you need a system like ArcGIS to be able to manage this large content. So as you know, you can have end-to-end capabilities to manage this robotic data flow, I don't know if it's from a drone. Also, we have partners that have satellites that now task satellites to actually get imagery that are required for whatever work. It's really that you want to not only capture this data, but also create some, information products out of it, whatever it is. But also there is a big trend at the moment to create 3D representation of the real world, whatever assets that you may have. So, and making it immediately available to, across the enterprise. That's maybe what's changing, is that in the older days, you had to really spend a lot of time trying to acquire the data, process the data, and be able to do something from that imagery. Nowadays, it's much easier. So the advanced imagery and data management capabilities that we have as part of ArcGIS supports, as you know, multiple formats. And I think that's maybe a key part of the platform, is that you can bring ortho photos, point cloud, 3D mesh, and anything like that. And you can do that so to ensure, of course, performance, interoperability, and good governance of good data volume. And you can see multiple examples here of reality capture, and they're doing the reality mapping, managing this data, the large volume like I mentioned. And the capabilities, of course, it's feature extraction, object detection, nothing new here, but the fact that you can do it at scale is really something that is what your organization is requiring today. Here's an example of a utility customer. They had their own actually satellite themselves, and it's a nano satellite, not something expensive. They collected imagery, 5-meter resolution. The revisit time was as they needed it, but was like more on a monthly basis. But they then combined this with other higher resolution data to get this type of imagery, and to do what with it, right? So what they wanted to do is actually monitor, for example, here you can see this is a construction site, and they wanted to monitor what's in red is anything that is new versus green was previously. So you can monitor the progress of the construction just from the satellite image, very macro level, but depending on the requirements, this is something that, of course, is very useful for you. More on the infrastructure itself, and here this is what you're seeing here is a transmission corridor, and they are monitoring anything that is shown in red under the transmission network that may not have a permit to have maybe specific things laid under the, in the corridor. So any anomalies, anything that is not supposed to be there is shown in red. Whatever is in grid is authorized. So you can manage, your network and your transmission network corridor this way. Good way to monitor. These are simple type of application and use cases, but you can see very powerful type of information. Now, let's switch to drone data here. So this is an example of Central New York Water Authority, and they leverage drone technology. Here, the first case that you can see on the left-hand side of the slide is a tank inspection. And you have on the right-hand side also a tank inspection, but the first one is the traditional approach, okay? So you can see here that you have scaffolding and people coming, so maybe multiple times someone will come to inspect that water tank, as opposed to the luxury of sending a drone, capturing the information and seeing any issues related to the tank. These are not maybe things that are that new to you, but I'd like to reiterate, the value of having to, the ability to use this imagery for safety reasons. You don't want to send people too often scaffolding. You can see how high that is. I'm Signal is lost, please. Okay, maybe. Excuse me, gentlemen. All right, so it's on and off. Sorry about that. Let's, Manoj, I'll let you handle it, please. Also, so we have some other examples. So you can see here, this was trying to justify from a business perspective. Here, also it costs money to send a drone, right?
Check
it's not just
two.
that it's not free. So if you look at there's some metrics that they provided here, that $10,000 for a tank inspection. Some additional costs, like plane charter, the cost of the drone, and so forth. Definitely the return on investment is there, that's for sure, okay? Here this was like before they rehabilitated the tank, so for condition assessments, not just sending the drone for the sake of sending the drone, and from a safety standpoint, but also really looking at the condition of the assets. And here is a telecom infrastructure, and so you can actually do more than just looking at some specific asset one at a time, but multiple. Continue, yeah. All right. So the water quality is sometimes very hard to reach some specific locations, even though they may have like specific sensors for measuring the quality or getting some of the samples. But sending the drone again is much easier access to remote parts, as you can see here from the left and the right. Okay, yeah, this one was also the telecom thing that they're doing. So this is another example of New Jersey American Water. Really to modernize how water infrastructure is inspected, documented, and managed. So you have multiple examples where they use, before you may have seen there was the GPR, they collect some data. Here's the drone during some specific construction projects. They're also capturing LiDAR data for the internal of their plants. 1, 2, 1, 2. 1, 2, 1, 2, okay, it's working. And then you have like the 3D reconstruction of some of the assets that were captured to make sure that they can also bring maintenance information attached to it and have this view. And the last but not least, capturing, doing a 3D scan before they actually pave the streets for all of the infrastructure networks that they are putting. Here in this case, it's a water network. So here we're looking at not water, but this is electricity overhead assets, as you can see here. And this is a very high fidelity digital capture for this overhead electric distribution network here in this case. And this was collected using aerial robotics and of course, advanced imagery. And there are also some drones that were equipped with high resolution cameras to capture. You can see here, you can see the poles, the conductors, the cross arms, insulators, spans, all the assets across the roadways and the right-of-way, without really putting a crew or multiple crews in traffic or at height. That's really the beauty of it. So these imagery inputs, they are then processed into engineering grade, like 3D feature, as you can see here on the screen. And then there is a buffer to kind of make multiple assessments. One might be vegetation management or any other type of assessment that they want to make. And this really allows utilities, I should say, to verify asset location, clearance, connectivity, and proactively identify, of course, risks like structural conflicts, safety hazards, and multiple other examples like that. So this is what we refer oftentimes as a living digital twin, and here this is the living digital twin of overhead grid assets. That's, the idea here is, of course, not just to create this for the nice visualization and nice rendering. It's not about entertainment, but really for inspections, for operations. That much in the GCCs. In the GCC countries, however, it does happen from time to time. We had those episodes in Oman, in the UAE, in Saudi as well. And, storm prepare, if you want to prepare better for a storm, that type of visualization and digital product will definitely help you. So again, all this powered by robotics, imagery, and location intelligence, as you can see. Now this is an example of, I want to make sure it plays, this one. Is it playing? All right. Aha. Is it?
Yeah, it's playing.
It's playing, oh sorry. This, my cursor, the cursor there, yeah. So, I'm not sure it does actually. Go ahead. Oh yes, thank you Manoj. All right, so here, this is an analysis of electromagnetic field. And you can see here there is an impact viewer that is available. And the idea is to help utilities assess exposure here, for example, validate compliance, and clearly communicate, power line impacts in the real world context. So it's a nice illustration of what you can do when you have that imagery being collected, the creation in 3D of your assets. And even here you can see it's not just the infrastructure assets, but also the surrounding and the contextual information, and making that assessment of what is the impact when it comes to electromagnetic field from a specific distance to that a transmission network. Actually, I see this very valuable for infrastructure organization as well as real estate. I think if new real estate development are done, they should actually show how far apart are they from a transmission network, and the value of that assets. If you're seeing from your door that you're not too far from it, it's not necessarily good, but the electromagnetic field is actually even a more problematic thing. In my view, personally, I wouldn't want to necessarily be closer. In my country, actually, there are some restrictions. If you're like 100 meters away, you cannot build a house that close to the network. I think it's the same here, but there are some compliance definitely that exist. Okay, so here this is, I don't know if you're familiar. Here I'm referring to another product that is called Gaussian Splat. And the idea is not to have great 3D representation, but something that is very smooth. So there is processing done on the imagery to a level that will give you the detail of some of the condition of the asset, as you can see here. It's called Gaussian Splat. And to be honest, this is where things are really going. I see many utilities around the world that are adopting this layer, and Esri supports Gaussian Splats. I think it's now a beta, but it's coming. So you can test it, and it's definitely available for condition assessment and then pushing the workflow for inspections and what have you. Just going fast forwards on this one. But you can appreciate here the level of detail that is represented as opposed to a normal product, which is just a normal imagery product. So nice processing and then visualization able to be done within ArcGIS itself. So very, very fine details, and you can see the objects here that are being shown in the video. Here's an example here as well, the difference between the Gaussian splats versus the 3D mesh. So you can very much appreciate the level of detail being shown and represented. This is showing how robotics and imagery extend beyond outdoor mapping, because what I've shown you up to now are more like outdoor or external, but there is also a lot done by some organization when it comes to facilities and indoor operations. Telecom organization like Vodafone in the UK, they were some of the pioneers testing this. But we also have other examples here, and you can see how the indoor environments are now captured using mobile LiDAR, 360 imagery, and robotic scanners, multiple of them, not just CAD drawings, right? I think when we think indoors, we think CAD, but there is much more that can be done and bringing that information. So the combination of combining outdoor and indoor really gives you an edge that you wouldn't get otherwise. So as you know, ArcGIS integrates, that reality capture also with BIM, so you can create a very geospatially accurate indoor digital twin. That's really kind of the end goal. And then the result is a single operational view of space, of assets and systems. And the idea really always goes down to the same thing, which is, you want to enable safer operations, better planning for sure, and real-time collaboration. I think collaboration is a topic we're going to come back on quite a lot, but the collaboration across the organization with this type of information product is really giving you an edge and helps you better run your business for sure. So talking about integration, this is an example of a customer in Spain, and they've been doing some integration with BIM. And as you all know, BIM is the information model, it's a model. So it's static, right? It's not dynamic. But when brought in with ArcGIS, with the GIS data, then you have a very different type of information, especially if you then also integrate real-time data, and the combination of all of those assets. So you can see here some representation of 2D data versus 2D, and then bring the BIM data, and then enabling 3D representation of some of those assets, whether it's GIS combined with BIM or just the BIM itself. So this is really a game changer of doing this type of integration. Up to this point, I would say robotics and GIS, have been about sensing and analyzing the world, but you can also, with AR and VR, know where the intelligence, becomes a little bit more human-centric, if you wish. So here's an example of your assets in augmented reality. And this was captured from a variety of sources, but the representation and visualization also combined with imagery gives you a very different type of perspective of issues related to the assets. So if there is a leak, for example, on your water network or your gas network, or an issue with your telecom network or any type of network assets or infrastructure, then it's easy for the engineers to actually see what's underground. That's really the main thing. Mind you, overhead, and overhead assets are also being asked to be represented in augmented reality, not just underground. Next slide. Okay. So, as you can see, and you're already, I'm sure, doing some of that yourself in your organization, you use ArcGIS, as a foundation, and use the imagery as a foundation, right, to build your accurate 3D representation. Here's an example. You can see multiple type of data sets. This is, rail network, utility infrastructure. You can see it above ground, underground, and you can also have BIM data of here in a train station. So you can see all of the assets being all brought together. And when you communicate and you try to collaborate with your colleagues, it simplifies the conversation. And as we all know, sometimes it's hard to communicate a specific information or message across. So that's really kind of the idea here. But it doesn't stop at just visualizing and better collaboration and coordination, but also doing specific analysis, like impact analysis. If there is flood, for example, what would be the impact? Maybe also on a sewer network, what would be the impact when there is vegetation that is growing? So how the infrastructure, here you can see that the infrastructure is moving from static data or just 2D data really to something that is more 3D and helping you to make those various assessments that I just mentioned earlier on. So, a lot on imagery. Hopefully that gives you a sense of what we can do and not just using like 10 years back imagery just as a backdrop in your information system, but really using imagery in a variety of ways. Now let's switch to AI, Geo-AI and Gen AI. You've heard during the plenary, there was some very good examples of Geo-AI. I'll reiterate a little bit what was mentioned. So like most technology companies, Esri is advancing ArcGIS with artificial intelligence. If you have used some of our AI models, you're already familiar with that. But our plan is really to do this in multiple ways. So the first one is Geo-AI. We have hundreds of models available already. And we've been doing this for several years, right? So machine learning, deep learning, object detection, change detection, you name it. We have a lot available there. We have also a lot of AI assistants, and my colleague Manoj will show you many of those very interesting stuff. This is really to help you in your day-to-day work, right? A simple example is, you don't want to do a survey 1, 2, 3 form from scratch. So can you help AI assistant, can you help me do that? But that's not just the example. It's a very powerful one, but there is much more, and Manoj, you will talk about this. And there is a Another one as well that is coming is Geo-AI. I think there was some that was presented before. But generative AI is also something that is very demanded in the market, and we'll show you some examples. So those, not spending too much time on those, but these are the Geo-AI tools and models that we have for feature extraction and analytics. We have our website. If you're not familiar with it, please go and view it. It's very, you can see these are the pre-trained and ready model to use. Not some of the new ones that are listed here. Text, we can recognize text in imagery, so I think, or in a PDF, or multiple type of things like that. So it's very, very good. I think the PDF one you have, yeah, you're gonna show that. A lot of things like 3D building footprints, classification. I mean, there's a lot also on wildfire because we have some issues in Europe and in the US with this, not here. But we needed, some of our customers there were asking for this, so we provided them with some models. But, we also have like one for transmission towers, trees, so much for ships as well. So a lot of things. I know that many here in the region have been using the palm trees one. It's just to see the condition of those palm trees and whether or not there is health issues with those. Okay, so here, it's just, I think I need to play it. Yeah, so this is an example of a Survey 123 assistant. So here, the idea is to create something from scratch as opposed to, something automated as opposed to something from scratch. And the prompt is create a survey for inspections. Okay. So it's a bit slow. The video is coming. Just keep an eye on it. This is for an electric utility. Okay, and this is a pole inspection specifically. So it will just, create what is needed for you, and then it can be generated easily. And here's the output. Very straightforward. How many of you have used this type of capability? This is beta version still, but have you played with it? Oh, excellent. Very good.
I found this on the web form.
Well, I didn't ask for help, but this is AI. You see how AI is everywhere? This is scary, huh? There is also another workflow here where the imagery, typically people have been doing the workflow where they would, have a paper form, then they moved to a digital form, which you had to kind of do yourself. And then they were taking an imagery, like populating the information and capturing an imagery at the end. Now the imagery is captured at the beginning, and then from the imagery, it will actually detect and provide a brief, a pole inspection on its own. Then you can confirm whether or not that, inspection detected automatically with AI is correct. And then it will populate, like, what type of pole is it? It's wood and so forth. So it doesn't mean that you're going to take for granted that everything you're not going to verify or validate, but it helps you with all those errors that people were having when they were keying in the information. Really, again, production being more productive in, in providing this application to the field users. Because the field engineers, they don't want to spend time filling up a form or whatever. They want something that is as fast as possible. So number of inspection will go higher for sure. I remember having a conversation with Oman. At the time it was MEDC, Muscat Electricity in Oman. And they were already, just with Survey 123, the first version of it, they were able to do 3 times more inspections. Can you imagine now, with these capabilities, how many more inspections they'll be able to do? It's quite amazing. And we take this for granted, but really the technology is here to support you. Okay, next one. Now this is generative AI. So I think you're going to be interested. And I would like to thank my colleagues so if you're not familiar, Moro is actually the digital DIWA arm of the Dubai Electricity and Water Authority utility company in the UAE. Can you play the video, please, for me, Manoj? This is a prototype that they've done internally. And here the idea is, so they have multiple layers and they want to ask some questions. So they're asking, so what type of question can I ask? they can ask questions about electricity consumption, water consumption, and they're going to say, okay, give me the top 5 communities in electricity consumption. And it's going to show the 5 polygons of where there is high consumption of electricity. Now, specifically in that place here, which is Karama, then they are saying, okay, tell me, Murakabat, in that community, what are the parcels with the highest consumption on this community? And then it will, find it. There is a LLM in the back end that finds the information, and then it will show you exactly where that is. Is the video finished? Yeah. Yeah, no, that's it. So shall I replay it, or did you see, because it was a little bit fast? But please replay it, Manoj. Now, the business driver behind, there is a law in Dubai that you're not able, unless you're the official tenant, you're not able to sublet, meaning you cannot lease to someone else. And there were houses with high water and specifically electricity consumption. That means that people, sometimes there were 10 people in a 1-bedroom apartment or 2-bedroom apartment. That's not legal, right? So they wanted to they could see how much electricity was consumed, which was unusual. There's an anomaly. If you have a 2-bedroom flat apartment, that consumption of electricity shouldn't be that high. So that was a way for them to know if someone was leasing something or not. And then they could continue the workflow on, whether or not they send, they go and knock on doors, or they send them letters to say you're not allowed, whatever. But to enforce the law, and that was really the main key problem. So I really love that example. It's a good one. I think the next one is the prototype for National Water Company. So, yeah, that's right. That's the one. So I've had a colleague in the office. He was on stage yesterday, Ahmed El-Husseini, a very good friend of mine. And we were discussing how we could prototype something, Gen AI, with ArcGIS Hub. So if you're not familiar, we have also a hub Gen AI assistant for you. And Manoj will zoom in, thank you. And here the idea was, actually we wanted to show this to National Water Company, but not sure if they are here in the room or not. But we did this prototype, and the idea was, maybe you want to refresh this? Yeah, lost the connection? The idea was, let me put a hub site here for access to customers. How many of you have called a utility company, water or electricity, and dial, if you want to speak to this department, dial 1, dial 2, dial 3. Before you know it, after 10 minutes, you're still on the phone waiting to speak to a customer services rep. And it's very frustrating. So having this ArcGIS hub site here, the idea would be that it's a one-stop shop where you can have information. Here specifically, you want information about water outages? It's here. Is there a water outage in my area? You will have all this information at your fingertips, okay? Or maybe like what are the infrastructure projects available, or information related to water consumption. But when it's actually interesting, is that if I am a customer of National Water Company here, in this case, I want to ask, is there construction happening near my street? And why is that? Is because I want to know how to maybe plan to go from A to B, and I want to know if there is construction and traffic. And the answer would be NWC is currently upgrading pipeline in your area, view the project location and timeline, and then you will have a link to the project map if you wanted to. But you're not prompted by the geocentric application straight away. You have a simple question, you have a simple answer. That's generative AI. Another example, I have, you've all experienced issues with water pressure. When you're, for example, wanting to do a washing machine or put the dishwasher on and there is no water pressure, or even just to wash your hands, right? That's a problem. So you may want to ask, why is my water pressure low in Al Madina, for example? And then it will answer, according to the National Water Company operation layer, there is an ongoing valve maintenance in your area. Just by reading this, suddenly my frustration is, okay, I now understand why there is no pressure. And up. We'll run it again one more time. Yeah, thank you, Manoj. And not only tells me there is this problem, but it says water pressure is expected to normalize by 6 p.m. today. Oh, now I can plan. I can go and do something else Maybe I go and grab some water from the shop or something to wash my hands or do something. But my expectation is managed, and that's really the key part. Customer experience for a utility company is very key. Delighting the customers is not easy because the customers, they don't interact with the grid. They interact with there is electricity or there is water or there is telecom. Now, okay, I know that by 6 p.m. I will be able to have water. And if I want to, I can even view the live status, service status here, which will, or maybe I want to file a report because I'm still unhappy because my personality is that I'm always, not happy. Now, let's say I'm a regulator. That's different, okay? If I'm a regulator, I will have specific credentials to be able to access this. But if I'm a regulator, I have different questions, I'm not, my question could be, what is the current non-revenue water rate in Jeddah? Okay, which oftentimes to get that information, there is a lot of documents and reports that have to be shared with the regulator. Here in this case, you will have the answer, the national rate, the non-revenue water, rate in Jeddah. It stands at this percentage, which is 22.6. You want to explore more details? And here's the dashboard, okay? So you can see here how the Hub AI Assistant is helping you to really have a different type of communication with your customers, with regulators, or any third party for that matter. So hopefully this will give you an idea of how you can, in your organization, think of integrating and implementing such an AI assistant. With that, I'll hand over now to Manoj to continue and talk about the AI framework. Maybe you want the mic, yeah?
Thank you. Thank you, Christel. So I'll be talking about the ArcGIS AI framework that has been. Can you hear me now? Okay. So we know that artificial intelligence is rapidly evolving, and Esri sees the power of integrating GIS and artificial intelligence and make ArcGIS become a geospatial AI platform, right? So how do we explain it? Now, we usually say that it is structured into 3 categories. The first one is Geo AI, and I believe many of you are already using it through machine learning and deep learning to advance the use of GIS. Now, we provide the tools, we provide the models that are used to extract the insights, detect objects across data sources, and that information or the result is then used for your spatial analysis. We have made strong progress in this particular area, and we will continue expanding these capabilities. Now, if you see, the second category is AI Assistant, and the purpose of AI Assistant is to enhance the experience of using ArcGIS and boost productivity. Now, over time, ArcGIS will evolve with smarter assistants that can interact with other tools, enabling better coordination, system collaboration, as well as smoother end-to-end workflows. Now here what I would like to show you or take you through is how Geo AI can accelerate feature extraction from imagery. Let me play a video. Those who have the headphones, they will be able
I have
to
some drone imagery outside of Denver,
see
Colorado,
and hear the voice.
For a building where we're getting ready to collect existing site conditions for an upcoming project. You might already be familiar with our pre-trained models that can detect features like buildings, trees, and roads. We can also train models to meet our own project-specific needs, like these markings we see running through the parking lot, representing underground utilities. Using Geo AI, I can train a model to even detect objects like this. The resulting model can be run whenever I need to automatically extract these objects, which can then be converted. I can repeat this process of training for additional feature types, saving me time from manually digitizing these to be incorporated into the planning and design process. We've seen an example of how Geo AI can automate feature extraction from imagery.
So here you have seen one of the examples where using deep learning packages, you can extract your features from an image, right?
Here,
Sorry,
I have some
let me
drone
go to the
imagery
next slide.
outside of Denver, Colorado. Here,
So this is another example where you can unlock critical information for analysis purpose with text extraction. The earlier one was feature extraction. Okay, this is text extraction, and how the AI assistants can boost productivity by helping us find the right tools for analysis purpose.
from imagery. Now let's see how it can unlock critical information for analysis with text extraction. We often receive soil boring logs in PDF format with valuable information like soil types and depths locked within each file. Normally, someone has to manually open each and scroll through to transcribe the information that's needed into a different format. This process can take hours. ArcGIS Pro has a tool that can help automate this process. At version 3.5, we introduced a new tool called Process Text using AI model to the text analysis toolset. Using this tool, I can simultaneously process multiple documents at once. Using a custom deep learning package that has been trained to extract text. This saves me time generating the data that I need for analysis. In the output, we can see I've maintained the same data points we saw in the document, like boring log number, location, depth, and soil types. I can also visualize these soil types with their associated depths. Now that I've converted my text to a more usable format, I'm ready to perform some analysis. Let's ask the AI assistant in Pro for some help on how to get started. Using the text prompt, I can simply ask a question like, how do I create a voxel layer from soil boring points? The AI assistant is combing through thousands of geoprocessing tools, finding the right ones to answer my question. Then it's generating a detailed step-by-step process and telling me where those tools fit into that process. This is something I would normally have to do on my own. ArcGIS Pro has a lot of capabilities and is supported with a rich and comprehensive library of documents. The AI assistant is saving me time by doing this process for me and then presenting the information back to me so I can make a decision on what tool I want to run next. I can see from step 1 that I've already completed it and have prepared my points with depth and measured variables, and then I'm ready to move on to step 2. Continuing to use the assistant, I can tell it to open all tools in step 2. The assistant is creating links to each tool and generating a brief description of its inputs and outputs, and then presenting it back to me. So again, I can make a determination on which tool will best suit my needs. After reading through and making a determination, I'm going to go ahead and run the IDW 3D tool because it both interpolates the points using machine learning as well as creates a voxel layer for me. The assistant is fetching the tool for me and will automatically open it in the map. Once it's open, it'll already have set the input to the soil borings, so all I have to do is pick the value field. In this case, I'd like to interpolate the soil types, so I'll select that and click OK. I now have a 3D volumetric model giving me a clearer picture of what is beneath the surface. Using the slice tool, I can explore what was once text in a document as a 3D model, revealing changing soil patterns as I slice through the different depths. We've seen.
So this particular capability, it has been introduced at version 3.5, and as you saw in the example, right, GeoAI, you're using it to extract features using text PDF files, anything. And then the AI assistants, they are helping you find the right tools to do the analysis that are required. Okay, and these are all using deep learning packages. Let me go to the next
Some
slide.
imagery.
So here I would like to show you an example of how Geo AI can maximize the value of your data by making it more discoverable, and AI ready with a new tool in GIS, which is called as the Item Details Assistant.
The new assistant is built directly into the item page for the layer and uses generative AI and item properties to suggest descriptions. I can now easily populate things like title, summary, description, and tags. AI is using the item properties to understand what the layer is, and then based upon that understanding, it's making its suggestions. What was once a tedious setup task is now a fast, intelligent, and consistent process. I now can review and make any edits as I see fit. Once I'm comfortable with what it's returned, I can go ahead and save this to my layer. I can repeat the same process for the fields, ensuring
You can use this for your fields as well as the layers that will be there within the ArcGIS portal or the services that you're going to publish.
the new assistant is built.
So till now we have seen how Geo AI and the AI assistants can be used to boost productivity within the office work. But now let's see an example where the same capabilities can also be applied in the field, right? In this video, you will see how Geo AI can be used to detect issues from drone imagery. You will push them out to the field for correction, and how the assistants will help you automate the data capture in the field, making the lives of your field workforce much easier by improving the quality of your data and improving the efficiency.
I'm responsible for all pole inspections in my maintenance zone, shown here in yellow. And I can even see from this red indicator that my scheduler has assigned me a critical repair job due to its proximity to my existing work. Let's select for this job and see what we need to do. I get a message that Geo-AI has detected that the topmost disc on an insulator on this pole has been damaged, and that I need to bring a replacement brown ceramic insulator disc with me prior to the field inspection. But how did it know this? I'm going to click that I've acknowledged and read this message and continue my form. I can now see that the Geo-AI insulator defect detection model was run on drone imagery collected down this main road, and it is highlighted in orange that this top insulator is damaged. I can even view the LiDAR from this drone collection in the field to help me quickly orient myself and guide me to exactly where that insulator is on our pole. Once on site and after I've performed the repair, I can say that I've corrected this issue and submit, continuing the rest of my inspections. Let's continue to this pole nearby that I need to do a manual inspection because we can't fly drones over the houses. And let's do a visual capture. Typically, taking a photo is the last step in an inspection process. I've just taken a photo of the pole that looks like this. And the AI assistant in Survey 123 using computer vision is going to complete the rest of my form, extracting from this image that the pole height is 35 feet, it's made of wood with 2 cross arms, 3 power lines, 2 joint use attachments, a guy wire, 2 transformers, and no street lights. It's even detected a vegetation issue 6 feet from the pole, but in otherwise good condition. But not everything can be observed at surface level. In this case, I'm going to do an audio capture and perform a sounding inspection. I'm performing a sounding on the pole, hitting the side with a hammer, and it sounds like the pole is hollowing, indicating rot. But I'm actually going to keep talking now and have these words recorded to see if AI is intelligent enough to cut through all the noise, because job sites are really loud, and only return the information that we need to complete this inspection. All right, let's see what we get. The AI-enhanced transcription simply says, I'm performing a sounding inspection on the pole, hitting the side with a hammer, and it sounds like the pole is hollowing, indicating rot. And that's it, improving the data quality of my capture. And the issue of rotting is even put into the appropriate place on my form. I can now complete this inspection and submit and continue on the rest of my work. So we've just seen how GeoAI can be used to detect issues from drone imagery, push them out to the field for correction, and how AI assistants can help automate the data capture in the field, making the lives of your field workforce that much easier and improving the quality of your data capture.
So the next thing that I would like to share with you is how the AI agents can be used to discover and explore data within Microsoft Teams, which most of you are using it on a daily basis.
From imagery, we're all familiar, and maybe too familiar, with Microsoft Teams. ArcGIS for Teams now has an agent that can be registered with Copilot, making content discovery even more dynamic. For example, find 3D content related to issues for a project, Highlands Ranch, in my ArcGIS Online. The first thing the agent's going to do is ensure it has permissions to access my online organization. If I've signed in previously, it'll go ahead and look for related content based upon my query, using the title, summary, and descriptions to match any related content. Then it'll return a brief description so I can review it. In this case, I've seen it's found a 3D GeoBIM scene, and it does contain layers like issues, as well as rail, infrastructure, terrain, and buildings. Once I'm ready, I can open this scene directly within Teams. This is giving me access to relevant project information coming in both from the field and other sources, like this coordination issue, as well as the building information model. ArcGIS is bridging the gap between people and places, and now as we move into a world of connected agents, it's enabling systems and workflows to talk to each other, creating action from data. From imagery, we're all familiar, and maybe too familiar.
So the last thing that we want to show with you today is the new Data Explorer AI agent in its instant app interface, which allows you to ask questions, right? So let's see that example. The last slide. It's very low.
But what if we question?
Here now.
How many service points are in a flood zone? This is an interesting question because it can't be answered with just one data set. Data Explorer has to look at all the authoritative content that we've configured it to have access to in order to discover what data sets it needs in order to answer my question. Then it has to use spatial reasoning to come up with a query plan to identify the correct geoprocessing task to apply to that data in order to answer my question. We can see that it's already found a service points layer and a flood zones layer, and it's going to use it. This is great that it keeps me updated with what it's doing while it's doing it. It's identified that it needs to use a spatial filter analysis in order to answer my question. This is great if I don't know what data I need or what tools I need, because all I need to bring to Data Explorer are questions. It just asked if it had permission to run the spatial filter. This keeps me in control of what Data Explorer is doing. Once I've given it permission, it'll package up my data with the appropriate configuration, submit it as a geoprocessing job, and once that analysis is completed, it will fetch the results and return them directly into my map, allowing me to explore them spatially. I can see that it's already submitted the geoprocessing job and that it's getting the service points that are inside any flood zone. The analysis is completed, and now it's just summarizing and fetching the results to display them here on the map. After they've been returned, Data Explorer zooms me to the area where these points are located, and we can begin to explore them in the map. I can even see the flood zone boundary that it used for this analysis. It concludes that there are 24 service points in a flood zone, and I can even ask it to show its steps and what data it used to arrive at this answer.
Okay. So today we have seen that how Geo-AI and AI assistants can be used to productivity, not only within the office, but also in the field, and how AI agents can be used to discover and explore this, the geospatial content that you have. So in the end, what we would like to convey is that ArcGIS is a geospatial AI-enabled system, empowering your organization with new and exciting capabilities. Thank you.
Comes issues, but we should be good now. Everyone can hear? All right, excellent. So we will have an hour together, questions at the end, because we have a lot of content to share. And we also have the privilege to have our customer, Neom Autonomous, who will also present with us. They've done a project with our partner, GDI, and they will present their digital planning twin. So today we will focus not just on a digital twin, but a 3D living digital twin. So things are evolving, capabilities are such, demand in the market are really pushing everyone to go above and beyond. And just, from when you hear the word living, you have to think real time. So what's happening right now, whether it's in my network or in any type of situation, right? So that's where the living word comes from. And 3D, I think you've seen between yesterday, today, and the first session we did with my colleague Manoj, how 3D is really taking a lot of precedence in everything you're doing nowadays, because it simplifies the conversation. So, sorry, please go back. So we will have Tariq and Ines joining us towards the end of the presentation. So please do not leave until they speak. And I also have, Prasad from Esri Saudi helping me out today on the session. He will share some excellent use cases of digital twin. I will also share some of those. And if you don't know me, my name is Krista Lorzik. I run the infrastructure sector at Esri, based in the Gulf countries here. There is a survey. Please provide feedback. Anything that is negative related to the comms or related to the venue, any experience issues you have, please share those, and then we will improve, of course, over time and definitely for next year. Okay, so next slide. So let's talk about some of the content we're going to share with you. We will review a little bit what is the digital twin, and the reason is it's not Esri that is defining what is the digital twin. We are part of a digital twin consortium. So there are many, many organizations that define this, and we provide, of course, a lot of input. So just want to make sure that we cover that topic a little bit. Why are companies using geospatial-enabled digital twin? What is the value and the ROI in doing that? The outcomes, what is it that you get out of it? And like I mentioned, NEOM and GDI will be presenting the work that they've done recently. Yeah, a bit. I will sit here so I can. Sorry, I will take. I will drive from here. So, like I mentioned, we're part of a digital twin. So we are adopting the digital twin consortium, and we're adopting their definition of what is a digital twin. And you can see here what they mentioned is that it's a data-driven virtual representation of the real world. So far, so good. I think everyone understands this. And processes as well. You can twin processes. You don't just twin the environment or the infrastructure or any contextual information, but also processes can be twinned. And then synchronized, of course, that's a very important part, at a specified frequency and fidelity. So the high fidelity, that's where the 3D comes in, and then specified frequency is, of course, the real time that comes into play that I mentioned earlier on. So understanding decision-making and action, that's really why you're putting and implementing a digital twin. That's really what you're trying to do to transform how your business is being run. You want to accelerate and automate as much as possible and make sure that the decision-making is based on some data-driven information. Outcome, use cases, integration. Of course, everything has to be motivated by outcomes. But what I see when I interact with organizations that want to start working on those type of initiatives, they want to jump straight away to the 3D representation. Please, 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 take the time to really articulate what are the business requirements. Because you can put out there a digital twin that might look so different from one use case to another. So it's not just I have one digital twin for my organization, but I can have multiple twins for an organization. And we're going to talk about those macro-level digital twins, which can then have different type of sub-twins as well. And the twins is not just now, it's also what happened in the past, what's going on right now, that's current, but also predicting the future. And that's really some of the things that you're hearing a lot about digital twins and AI wanting to do a lot of prediction, especially in the infrastructure sector, that would be predictive maintenance. But we don't want to stop at the planning and the predictive maintenance, but there is also in real time what's happening, right? So that's why we are referring to the 3D living digital twin. Now I'm going to show you here a video that is some work that we are doing with the city of Zurich in Europe. And you will see the type of data sets that they are using to create this digital twin and what they do with it. So we show some use cases. So see the very high fidelity look and feel. So let's take a look at the data integration piece. We have some data coming here from the Living Atlas, the 3D base map. We have some charging station in the interior, not just outside, but also interior spaces. Here, some BIM data that is brought in, not just, so that representation, very high fidelity of a design is brought inside the GIS environment. Maybe some bathymetry information, right? It's really a variety, soil types, like you saw early on when we were using text, to bring it. But also time can be integrated, right? You can explore the past, and you can also, use the time slider capabilities that we have to show this and to show how things are looking over time. You can simulate the future. That's really a good example, a use case of, and analyze also the future. Like for example, here there was visibility studies that was done. Here in this case, some additional data sets that are brought in. You can simulate the present. Here it's a fire, right? So maybe you have some motion sensors. Maybe you have some temperature sensors. Some use cases, very typical environmental type of use cases. Here in this case, this is the decarbonization analysis that is done. For urban planning, I think that's a major thing that all of the GCC countries are interested in. urban design. You can see here with City Engine, we have the capabilities to do some very advanced representation of how a city would look like. But like I mentioned, it's not just outdoor, it's also indoor. The wayfinding, for example, here, you can explore the route in 3D. I mean, look at the complexity of being able to bring this together. And you can do that with ArcGIS. I mean, that's the beauty of it, because it integrates all type of data sets. You can also process whatever data you have to make it, according to your use case. Here, you have additional information. This is more the facilities management that are being shown, and that can be, the color code can be according to different type of assets, but also the condition of those assets. Here, this is the maintenance information, cost associated with the maintenance, and so forth. You can see how far you can go. So I just gave you at the very high level how a digital twin, could look like for a city. But you can then, apply it and project yourself how it would look like for your own organization. So oftentimes I get this question, which is how actually, what are the type of maturity level of digital twin that exists? And organizations have done a lot of work here, especially 10, 20 years ago. It was digitized, so yes, it was digital assets that you had in your, geodatabase, but it was really a virtual representation of your physical assets or your network infrastructure, whatever, but descriptive, right? So the technical description of those assets, maybe some integration with other systems, but it was more descriptive than anything else. Then people start to say, you know what, I want to understand also what's going on right now, so show me the real-time information as well. So that starts to become a bit more informative. Okay, I have water leaks there, and there. There are a lot of issues there, in this place. Those type of things, like real patterns. Where things are going is more on the predictive side of things that I mentioned. Fully comprehensive, where you can do actual scenario and really see, the outcomes and some maybe recommendation. And very further down the line, some organizations are really aiming at autonomous. So autonomous, let me give you an example. That would mean, for example, let's say there is an electric outage somewhere, okay? You wouldn't go and task yourself manually the drone to actually take off and go and inspect an overhead assets, for example. But the SCADA system will trigger the drone to go and fly and do the inspection and come back. Imagery will be collected, processed, and then the information will be provided to you on decision making, what would be next. This is very much advanced, autonomous. I don't know of any organization doing that yet, but many are wanting to do this. I get a lot of RFPs landing on my desk, and some of those were 2-3 years ago. Transmission electricity organization were really looking at that because of the large service territories they were having, large inspections of assets they had to do for their overhead networks. So these were things that made sense, but the reality of it 2-3 years back was a little bit challenging to do that. Not sure where they're at today, but that's where things are going. All right, so I think there are a couple of slides. I'm going to go fast because I don't want to take too much time on the presentation from my colleague Prasad and the NEOM guys. But obviously, the idea of having a digital twin is really to support the full life cycle of the infrastructure, then from plan, design, build, operation, and maintenance, as you can see here from this slide. So outcome have to be really thought through carefully. And I want you to really take a minute here to not just think of, if you have infrastructure assets, of your twin, of your network twin. Don't just think of that, but think as in your organization, you may have a design and construction twin, right? You may have an environmental twin. We see this a lot, especially in the US and Europe, because they are facing external weather constraints, whether it's fire, wildfires, floods, heavy, weather-related issues, and they need to monitor those type of environmental conditions that are impacting the infrastructure. So they need to implement an environmental twin first and foremost, not regardless of how detailed this one is, but this one needs to be quite advanced, okay? And oftentimes it goes 3D also. Operational twin, we're going to talk about that, and I'm going to show you an example of a water organization doing great work in Malaysia. Last but not least, emergency. You know, especially nowadays, you know, we want to make sure that in case of an emergency, whatever the issue is, you want to make sure that you have still, you know, the service being provided by the infrastructure organization. So here's an example of environmental twin. You got quite a few screenshots here on the screen. And the idea is really to provide this unified, special environment to monitor the climate or the ecological or natural resources conditions in real time, right? So you can enable scenario modeling to understand like impacts of heat, impacts of floods, air quality, biodiversity, and land use change, of course. You know, that's for sure that maybe the top one actually to think about. And here the idea here is to really support mitigation planning, identifying vulnerable, whether it's communities or vulnerable areas in your infrastructure, things of that nature, and anything that is high risk, right, within the ecosystem. So it integrates sensors, it will integrate imagery, and simulation data as well can be used to improve all the environmental forecasting, as well as you know, early warnings capabilities. That's really what you're trying to get at. And that's the, you know, the bottom line is that from an outcome perspective, you want to communicate complex environmental insights to clearly you know, help the policymakers or anyone, you know, the public or any partner of that that is involved. I was mentioning about environmental twin. Here's an example of how you can forecast and simulate. This is wind, and then the impact on maybe specific structure. And you can see the visualization and how this is helping and simplifying the conversation for anyone who needs to deal with those type of situation and problems. So this is another here example of a project review related environmental analysis. It includes a lot of information, noise, wind, air quality impact, and things like that. This is more to evaluate development proposals and design options within a city. Planning twin, we will talk, we will have the example of NEOM later on, but here the idea is to evaluate like land use zoning, development impacts, and really enable those data-driven scenarios based on various strategies, and establish KPIs, as you can see here on some of the dashboard information. And really, from an outcome perspective, you want to enhance public engagement through those interactive visual storytelling of future plans and developments. Is there a video here? Yes, it's kicking off. So this digital twin here, this is for carbon intelligence. And this is really bringing this into urban design. So each building here in this case is modeled in 3D, as you can see, with embedded data on materials, energy use, and performance. So the system will calculate you know, the CO2 emissions in real time because of the sensors that are available. And then it will allow the planners here to compare different scenarios, as you can see here on the screen, to see the impact of sustainable choices. I mean, that's really what's on the agenda today, is making sure that any decision is made according to you know, the sustainable goal that the organization or maybe a country may have. So it turns the sustainability from a report type of information more into a live, measurable action tool, as you can see here. Design and construction, I think it goes without saying that BIM plays a lot, and you can see the integration with BIM and GIS. If you may have seen some previous examples also in the sessions that I did early on, and also in the video of the city of Zurich. And you can see here how this is improving coordination and also reducing any risk associated with whatever projects. So ArcGIS GeoBeam, let me make sure it starts here. Do I start it like this? Okay, I just had to click, sorry. So, as you know, the ArcGIS GeoBeam, it connects the world of design with the reality of operations. Here's an example here. It brings, like here, the BIM model into the GIS and geographic context. So that's linking both the real world location as well as, imagery and operational data. That's really the power of it. And by integrating those design models, the site conditions, and the live information, you then enable your teams to visualize and analyze and manage your infrastructure as a single digital twin. That's really the idea behind it. And the result, again, outcome-driven, that's better coordination for all of the players involved in those construction projects. Faster decision-making for sure, and then a clear path, right, from design intent to operational reality. Network twin, okay, that one is one is dear to my heart because, of course, I've been doing utilities for more than 25 years now, so that's a field that I'm very passionate about. And then the ability now with ArcGIS to really model as close as possible to reality any network infrastructure. That's really the power that we provide with our utility network. So you can twin your network and twin your infrastructure to do whatever that is required according to your requirements. So if you're a water organization, electricity or gas, you have a lot of issues, whether it's losses along the network, whether it's water leaks, electricity outage or what have you, or gas outage, you want to make sure that you manage that properly. So we have the ability to bring the operational data as well, close to the network twin, and that's something that is very powerful. On the design side of things, this is an example of one of our utility customers from Pacific Gas and Electric, PG&E, and that's their planning twin. So what they do is they're looking at the next wave of energy demand. So they have, over the coming decades, they expect up to 10 gigawatt of new electricity demand. So you can imagine that they have to really think and plan on how to do this. And that's really driven largely by data centers. No surprise, I mean, with AI, everyone knows that now a lot of data centers are required. But that organization has to really account for this and plan for this. So they need the digital infrastructure available for them to do proper planning. And they use ArcGIS to bring demand forecast, proposed projects, existing grid assets into a single location-based digital twin, as you can see here. Extremely powerful in my view. And I think, it's applicable to any of your organization that are trying to do very similar things. So the planners, they can see where the new load is emerging. They can also assess the proximity to substations, transmission corridors, and understand all of the constraints at a neighborhood city scale type of location. So they can prioritize investments, of course, coordinate with cities and developers, and accelerate the grid readiness to the demand that is from the customers as well as the data centers. So the long-term energy planning is done here into a spatial environment, as you can see. Operational twin. So this is really bringing the real-time information. Rather than speaking too much about it, let me show you an example quickly on this one, which is this Malaysian company. So
AIS Selangor is Malaysia's largest water services provider, responsible for sourcing, treating and distributing water to consumers in Selangor, Kuala Lumpur and Putrajaya. Our mission is delivering the best experience to our customers, and our vision is to be Asia's leading water service provider by 2030, serving 9.62 million consumers with clean and safe treated water. To support our digital transformation into a future-ready utility, we have implemented action plans leveraging the latest technologies. This positions us to lead in Asia by 2030, backed by numerous certification and awards. We aim to enhance our big data analytics capabilities through artificial intelligence, machine learning, and digital intelligence. Our digital drive focuses on two core areas: talent and technology, powered by data. This shift emphasizes a culture of analysis and innovation. Rapid digitalization facilitates quicker, informed decisions, enhancing our mission. We use digital tools in planning, operations, and maintenance, aiming at the implementation of digital twins.
Geographic Information Systems, or GIS, has been integral since 2005, starting with data from SB drawings, on-site surveys, and information provided by experts and experienced operational staff. By 2009, we fully mapped key water assets, pipelines, reservoirs, pump houses, and meters using ArcGIS. In 2010, we launched IceMap, our web GIS system, which provides essential information on water assets and supports real estate development water applications. As the head of Planning and Capital Works Department, I want to highlight the vital role of GIS in enhancing our decision-making process, especially in planning and taking over approvals. Given the volume of applications that we process daily, a timely and efficient decision-making is essential. We have integrated GIS into our dedicated applications, ED+. This integration provides a comprehensive view of our water network assets, helping us to assess the impacts of the proposed developments to the entire system.
IceMap is fantastic, but it lacks of one crucial element: insight. In the geometric section, I need to keep track of our KPIs and monitor our progress. Previously, we had lengthy meetings, and updates came in bits and pieces. With the demand for digitalization, timely access to update information is essential. That's why we initiated the D15 Plus project, developed by a team of 15 in just 5 months. D15 Plus is special because we chose to break away from conventional methods. Instead of outsourcing application development, we invested in our team's growth and embraced the latest technology. We partnered with Esri Malaysia to conduct assessment, provide training, and host 3 dashboard clinics. The results have been impressive.
When I get a task, I think about what information I would find crucial if I were the boss. That mindset guides me in gathering data and building the application. And I'm always amazed by the result.
As a younger generation, I see the trust placed in me as a real honor. I did my best and it is satisfying.
I'm responsible for health and safety in our section, and the permit to work dashboard has been a game changer.
Efficient.
Success. Reliable.
Impressive.
Superb. We proud
Of ourselves.
At Selangor, we strongly believe in people development. We dare to embrace technology. The D15 Plus project.
All right, hopefully you enjoyed that one, right? You can see not so much 3D, but definitely real-time information. You could see all of the dashboards, projects that they've done. Did you notice just 5 months, right? They were able to implement this, so it's quite amazing. Emergency, like I mentioned, this is something that is very, very popular, trying to twin emergency type of situations so that they can better plan for it. And at its core, you know, the twin provides here a common operating picture, bringing together the real-time and authoritative data to the leaders, the responders, and the operators that are working from the same situational awareness type of situation before an event starts or during an event. Same thing here, I'll pass on. And then I'll move on to my colleague. Please, Prasad, go ahead. Yes. While Prasad is connecting, any questions so far? We good? All right, let's go.
Hey, hello. Are you able to hear me? Yep. Hope you have been having a good time at the conference. In the previous sessions, we have seen all the 3D digital twins and how they are delivering values to the organization. Crystal showcased how we can bring digital twins to life with sensors and live data. I will show you a few examples of live twins, and hopefully you will be able to relate them to your use cases. How many times have architects, planners, and operators wished they could predict human movements? Visualizing crowd movements is very important for efficient operations, safer evacuation, and help optimize space before issues occur. Here we have uCrowds, a software solution for simulating crowds in big infrastructure and large events. The product is based on 20 years of research on crowd simulation. The software creates an exact representation of walkable space in 3D environment. The video is demonstrating what happens when geographic intelligence, I'm sorry, is it working right? Yeah. What happens when geographic intelligence meets, I'm sorry. Okay. Meets human movement simulation. You get a digital twin where people, places, and data come together to reveal how the world really works. A digital twin with pedestrian simulation combines geospatial data with realistic models of crowd behavior. It allows planners, designers, and emergency services to test scenarios. How do people move during peak hours or large events? What happens when a road closes or a new transit hub opens? How can we improve safety, comfort, and accessibility? By bringing stream simulation outputs into ArcGIS, I don't know. Is it working now? I think it's the lag or something. Yeah. Okay. So the product directly connects to the ArcGIS platform using WFS services, and you can get density maps, and you can visualize them in 2D maps and 3D scene viewer. I'll let the video run for a while. Yeah, that's the 3D scene viewer. Okay. Hopefully the video runs. Oh, something's happening. Okay. We may all be aware of how location technology helps in finding ideal wind sites. Intermittent energy production has been a major challenge. It's getting stuck. Yeah, sure. Is it working? Huh? Is it working right? Okay. Okay, let's see. So having live 3D digital twins at their exact geographic location provides real-time performance visibility with live feeds of wind speed, power output, vibration, and temperature. Operators can immediately see underperforming turbines, identifying issues such as wake effects, yaw misalignment, or blade soiling to take corrective actions before energy losses accumulate. Sensor data fed into a 3D model can detect early signs of mechanical stress or failure. Abnormal gearbox vibrations appear in the digital twin weeks before failure. Timely ordering of spare parts helps in mitigating supply chain issues. This helps avoid unplanned outages and crane mobilization. By monitoring the wind forecast, operators can better plan the utilization of battery energy storage systems to increase revenue. Inversely, operators can visualize which turbines to curtail to minimize loss during grid congestion. Blade inspection using drone data visualized in the 3D digital twin is an upcoming strategy to improve safety and remote operations. I don't know what's happening. Okay, let's hope it. Is it working right? Okay. Okay. With 3D digital twins, utilities gain, I don't know. Gain real-time visibility of substations, feeders, transformers, and assets. When we start bringing SCADA, AMR, DER, and workforce data, we transform the digital twin to a living and learning system, giving us three things: early warnings on problems happen, continuous predictions, so I can better position myself, and dynamic optimization, optimizing the way it runs, so I do it at least cost or with the most performance. Utility assets have a lifespan. Oops, I'm sorry. Yep. Utility assets have a lifespan of 20 to 30 years. We have aging transformers, switch gears, and overhead lines exposed to heat, dust, and humidity. The living twin can monitor condition data and help with early detection of transformer and breaker degradation. Now is when we need to do business process transformations. It's not enough for the twin to tell you something, but we need to transform our normal processes to absorb the information and act on it. Now I will diverge a little from the 3D aspect, but will try to represent a strong real-world example of GIS digital twin that is delivering value beyond traditional infrastructure cases. Here we have Cisco's Service Delivery Insights platform, a digital twin of its global service supply chain to manage logistics and field service delivery in more than 130 countries. It uses GIS as a core engine for location intelligence and real-time operational awareness. SDIP integrates data from logistics, field engineers, planning, order management, and sales support into a geospatial model that represents warehouse, technician, service coverage areas, and the actual road network. It calculates travel distances, delivery times, and logistical constraints to automatically assign the best warehouse and the technician for a service request. The system uses business rules and GIS to automate what was once spreadsheet-based decisioning, dramatically increasing speed and accuracy. This example shows how a digital twin can extend beyond physical asset monitoring to include service logistics, inventory networks, and workforce dispatching, illustrating that digital twins can span systems, people, and process, and not just infrastructure assets. So with this, I hand over to Anas for the next session.
How do you feel? You can have it. Thank you. Hi, I'm Tariq Khan, Head of Transmission in NEOM Tech and Digital. And with me is Anish, who is the Engineering Director in GDI. So today what I'll be talking about, like, it's not only going to be maps. I'm going to be talking about the AI-ready future of NEOM, the way how I'm going to walk you through the journey that we are taking. And this is the agenda. First of all, we are going to be discussing so every project has a history behind it, right? So we in NEOM had some pain points which I'm going to be discussing first. Then secondly, we are going to discuss that how we conceived this project, and with the help of GDI, Anis is going to represent how the technical solution was. They supported us. And in the end, we are going to wrap it up with the OSS transformation readiness. So, so the first thing that I'm going to say is that when NEOM started, we had very aggressive timelines. This was the most aggressive project in the region. And people over here found out an intelligent way to overcome all the obstacles and the delays. So what we essentially started doing was that slicing projects into chunks and then giving the projects to the subcontractors so that we can meet the timelines and deadlines. But at the back end, something else was cooking, which nobody realized in the beginning. So the thing is, different contractors from different parts of the world were working in NEOM, and they were providing their inputs into all the as-builts, all the documentation, everything. They were using their own terms. Sometimes, for example, a manhole is called manhole. Some other would say a closure to a manhole. So there are just some issues of terms as well that we were having. And ultimately what happened was that the data was not consolidated. So we didn't have, and when we need to go and dig into the data, we had to go into too many different folders and too many different places. So this was all haphazard. The other thing that we were having was that as part of being registered in Saudi, we have to update CST of what's going on, and that has to be done in GIS, basically. So this was another key issue that we faced, and the clock was nearing. The timeline that we were given to produce all these documents and submit to CST, this was coming in. So this was basically the motivation behind the issues that we were faced, and then ultimately we went to GDI, who supported us on building this solution. The other thing that we were having was that, with so many projects ongoing, by the time we would go and deploy something, somebody else have already come and deployed their own equipment in the equipment room. So this was another issue that we were facing. So to minimize all these risks and issues, then this became the motivation for this project. Next one. So essentially what we conceived was that we are going to build a network planning and inventory tool. So what this tool is going to do is that it's going to create a digital twin of whatever we have in the ground that's going to be reflected in a tool, all the inventory, everything, and which is going to act as a single source of truth for all the projects moving forward. It's going to be the same for every department. Some departments, like, for example, the one in the execution, they were more aware of what's going on in the ground than, for example, the business department or the other departments. So to eliminate all these information in the silos, we conceived this project. So the solution was to work on a tool where we have everything, what we call as the as-is information of the network, what we have, what we are going to build on top of it, and at the end of the day, what is going to be the total inventory that we have. So this is what basically the main motivation was. Next, please. So this is just a bird's eye view of the way we do projects, and most of the companies, they do projects that design gets approved, execution accepted, and as built, and then it goes into the next phase. So this is how we were doing projects. So with the help of GDI and Esri, basically we built this part. So where we have GIM, Geo Inventory Management from GDI, and then which sits on top of Esri's ArcGIS. And if you see that, this layer has been incorporated with this layer, right? So at GIM level, what we have is that we have eliminated the gaps between PMO, all these departments, and then as the project is moving forward, everything is being upgraded on the system so that when ultimately the project gets finished, sales and operational teams are ready to take over from there. So there's no lag, no gaps. They have the full visibility. If this team has to, or let's say this team has to give connectivity to someone, they can exactly check the gym during the project execution, and they can forecast by when the project is going to be completed, by when things are going to be completed. So everybody is well aware, and they don't rely on communication gaps. So this is what we achieved. Next one. Now, just to give you an idea, just to let you know where we are moving, I need to first discuss where we started off from, right? So we started off with, we used to do the infrastructure projects based on the old, let's say, old school technology. Like we would have KMZ, we would have CAD files, we would have Excel files, and all these files scattered in our database. So this is how, when we started, before conceiving this project, this is how we were running our projects. And sometimes the issue that we faced was that there were no, when the files got upgraded, they were not updated on all the systems. So different people having different versions of the file. This is where we started off with. And ultimately where we went is this, where you see that all those silos have been eliminated, and now we have a central database where everything is up to date. And these are all per the international standards, complying to all international standards, and this is where we have a central database of how we move. Next one. Now I'm gonna hand over to Anis, who's going to discuss the solution part.
So thank you very much.
Yeah.
So basically, look at this circle from inside out. So basically, once the data has been designed and constructed, it is in as-built state, and it is located in the unified inventory, geo-infrastructure management. And as Tariq mentioned, it is used by different departments. Go back, please.
Sorry. This one?
One more.
This one.
It is used by different departments. So basically by sales, field service management for operations, in order to achieve their KPIs, so key performance indicators. Of course, it has been presented in the dashboards used by processes. The data is also located there, as finally reaching into unified asset management for different kind of infrastructure and equipment, such as passive network, microwave, transmission, radio access, and so on. So basically, this is the solution. So this is the first step, as Tariq mentioned, the designer part. So in the designer is used, basically, is the starting point for any operator who wants to do greenfield building or brownfield building of the telecommunication network. Over there, you can utilize the existing infrastructure to continue the work on top of it and expand, or from the scratch, from the beginning. So basically, you design the drop cables, splices, cross connections, bill of material, BOQ, and basically all the documentation that is required to do the building of the network. And it uses the algorithm for the automatic drawing of the network. So once you know what you want to do, you automatically create the network, automatically create the manholes, and the cross connectivities within the manhole. Once it has been designed, and constructed, it is in the as-built state, so it is entering the inventory. So again, as you can notice in the previous slide and on this slide, the underlying technology is Esri, and on top of that is geo-infrastructure management. And here, you put it into operations. So you have a network management native solution where you can configure data and the data models from the inside plant, which is racks, stories, cross connectivity, and the outside plant from ducts, fiber, and so on, of course, and bill of material tools. All of this in order to support the business process. Of course, since that was a desktop solution that is used by highly experienced telecom engineers, it's somehow more dedicated to them, but also to be used by the wide organizational team, there is a possibility to put it on the web. So to access through the web for the viewers, for the slide editors, utilizing Esri portal. So basically we have ArcGIS server, we have Esri portal that is reading the data from ArcGIS server, of course putting it on the dashboard for some management to see the progress, to see what has been constructed, what has been utilized, what has been activated from the network, and basically tracing all the changes. For the field teams, there is a mobile application that basically enables them to capture, edit data, and view any changes on the network, do some redlining, data survey, and so on, and which is quite nice. It works in the online and offline mode. So basically, this is the technology behind the solution. So of course we have Esri, which is the base. So from the enterprise server, monitor to see the utilization of the processes, the RAM, and of course the viewer user types and highly advanced professional user types. On top of that, there is GIM server, web, designer, and inventory. And all of these technologies together give the solution the possibility for the planning team to actually do their work and prepare for the next phases of the project. Yeah, next one.
The list of assets. These are all the assets which we successfully migrated onto the data model, GIM data model from GDI. So essentially what we have done over here is that we have made sure that anything that's in the ground, a digital twin of the same thing is being replicated in our digital platform. And this is just an example of all the things that are now in our inventory list. Next one. So now this is the end result that we achieved. Here you can see different, so these are different versions of the network that we have. So this one is the biggest chunk. It's a 400-kilometer fiber laid at the coastal highway, which we mapped onto the GIM database. And it's not just a map. It's like, map. Yes, at the back end is the Esri's ArcGIS, and at the top sits the layer from GDI, and which has all the data sets in it. So it tells us like what the fiber type is, what the chambers are, manholes are, if there is any diversion, how many cores diverted to which path. So this is all that we have captured in this. And this is just an example of one of the camps that we have in NEOM. This is an island, and this is another camp that we have. Next one. Now, over here, this is what we basically, how we are moving forward. like we are like building the base for the OSS transformation. And you see the planning, the rollout, operations, and then the as well. This is all that we have built. And Anish, if you can, give more details. Yeah.
Thanks. So as Tariq mentioned, basically they are building the first brick in the OSS project, which is planning the design of the network and putting it in the inventory. For the second phase to be used basically by the sales team in the CRM, doing the feasibility check, communicating with the order management to do some fulfillment. In this case, what is the meaning of the fulfillment and the rest of these components that I will just describe quickly is the activation of the new customer, so providing the internet to the user. So in order to do that, the dispatching team utilizes workforce management that in the backend is communicating with the BPM, the business process management, to do the activation of the service and to talk to the element and network management systems to provide this service. Of course, by the discovery components to put and update the inventory with all the new customers on the network. And eventually, having a report, operational report in different formats and in dashboards to see what is the number of the customer that has been activated, what is the numbers of the household that has been reached, and basically having this giving the possibility for the other ISPs, external wholesales, and the regulator to activate and provide service to end users.
Okay. Now, to wrap up, basically what I would say is that what we achieved is that, first of all, full compliance with the regulator, which is CSD. Then the second thing is that we have a platform which is integrating all the assets that we have. Being an end customer, I would define this as like, just like a human body has all the vital organs, right? But the thing is, you need the nervous system to work perfectly fine so that all our organs can work properly and maintain human body. I would term this solution as the nervous system, or let's say the digital nervous system of our backbone network. And then we have a centralized capacity management, inventory management. This is what we achieved. This is the transformation of how we are moving forward. And this red dot that you see is what we want to achieve in future, which is going to be a fully autonomous network, which is going to decide for itself, which is going to process things itself. So this is where we are aiming to go at the end. Thank you very much. Have a great day over here. If there are any questions. Yeah. Okay.
And also what's good is that you are not going through what people used to do 10, 20 years ago, where they used to actually...
No? It's good? Excellent. Okay, so again, Assalamu alaikum jami'an. Good afternoon, everyone. It's a great pleasure to have you here today. My name is Gaith Al-Sahib, and I'm the Business Development Manager, and I look after the transportation and logistics sector at Esri, Saudi Arabia. Today with my colleague Christelle Ortzik, who comes from Esri Global. We're going to give a couple of presentations where we'll talk about the global transportation challenges and how the usage of GIS can help us overcome those challenges. In addition to that, we have a very distinguished customer of ours, Saudi Rail. We're also going to give a quick presentation on how they use the GIS and how they were able to overcome the challenges for better planning and efficiencies. So the session is about 3 presentations. We're going to start with my colleague Christelle. Afterwards, I'm going to deliver a very quick presentation, and finally, our guest from Saudi Rail with Mr. Fahad Al-Sanad. So without any further delay, I'm giving it back to you, Christelle, please.
Yeah, maybe just for the survey, say a few words.
Okay, very important note for the survey, guys. So after the session is over, please feel free, to give us your feedback using the application. We would like to know, what went well, what went bad, so we can keep doing the good things and also improve the things that need some improvement. So yeah, Christelle, the floor is yours.
Thank you. Okay, you can hear me. All right, so we have a presentation that we haven't done in the past. In the previous Esri Saudi conferences, we were always dealing with the infrastructure as a whole, but there is a lot going on in transportation. And when I say transportation, I'm talking about those type of categories, right? So these are the sectors: airports, seaports, public transport, rail. And this is why we have the pleasure to have with us today Saudi Rail, who will present operational cost, and even more so than 2 decades back, I would say. Real-time and predictive insights is really what they are looking for. And of course, GIS, as you know, can provide those capabilities and solutions. So it allows organizations to do much more with their existing infrastructure, and they can plan smarter. I think planning is a big part. You have an existing network. I know there is one running from Medina to Mecca. I'm not too sure about the rest, but my family has used it, so I know it. But the rest, I believe you are planning more and more of extending your rail network. So at the strategic level, GIS supports emission reduction, and that's what we're going to be addressing as well with the example of Europe. Renewable energy transition is a big driver, as well as resilient infrastructure once it's built. It's one thing to plan it, but let's make sure it's resilient. So let's cover now the trends in transportation. Digital transformation and digital twins. We had a session earlier on this, but that's really becoming foundational within those organizations. And that's to enable rail corridors, airports and ports to move from the design models, right, to something that is more operational system of record type of situation. So the idea is to support, with GIS safety, security, as well as resilience, and making sure that all the issues that are happening are taken care of, so you can also provide real-time situational awareness for all of your operation, maybe do things like port incident response or airside safety, things of that nature. There are multiple other trends here listed. I think one that is quite interesting is the smart mobility. And this is something that even though you are planning the infrastructure or you may have the infrastructure in place, sometimes some people don't know about the fact that there is that infrastructure. Maybe there is a new metro station or there is a new rail station, but it's 3 kilometers away from my house. I don't want to walk there, right? The weather conditions are not that easy. So how do you encourage the people to use that station maybe? So those are the things that in airports and seaports, we see also they have a lot of utility networks to manage. So more and more of those, and I think, Gates, you have a great example on this, has to be considered, and that's part of your ecosystem of digital geospatial data that you need to maintain. So it's strong data management around it, but also how do you use it and apply it to make sure that, again, service is provided or experience of the customers using your infrastructure is great. We talk about integration with BIM. A lot of organizations are doing that, and I'll show you some examples as well. So from the trends that I mentioned, for sure you would want to have a platform that can support all type of users, right? Because there's no need to put all this valuable digital assets and not support the entire organization. So just what you want to do. You want to support the field guys, you want to support the design and the planning guys, as well as people operating the network. So these are all of the type of users that are supported. In terms of how GIS is applied in transportation, definitely on the data management side of things, because you have so much data that you need to take care of, and that's the geospatial data. Land is a big part. It's not just infrastructure. And we'll talk about this, how actually in Rail Baltica, land management is one of the big aspects of it. So your own land information system in your organization, your own infrastructure, so managing all this data and the imagery that you're collecting that is now being used a lot. So collecting the data in the field. Provision your users in the field with the data that they need to collect or to inspect, whatever type of workflows they're doing. Managing the network, we kind of touch on it, and the integration. So this is more like technical, and now we'll cover more at the business level how it works. Here, this slide, so you want to enable your infrastructure from a data-centric type of angle to make sure that you can support all of your users. So you will want to have environmental data, your transport network, human movements maybe, the mobility, smart mobility that I mentioned before, IoT, so any sensors on the grid, your engineering data, your BIM model, your CAD data, your utility networks data, and last but not least, your robotics slash imagery data coming from remote sensing, drone, or even the human beings themselves or sensors, right? So a field agent in the field doing an inspection, taking a picture, a photo, has the condition of the asset in the photo, right? Sometimes. So that's also some data that needs to be taken care of. And these are all of the integration that we've seen in the market. These are the things that are required to be integrated with ArcGIS. And it's not just BIM, but it's also maybe SCADA for alerts of any issues that's happening. Scheduling, and especially scheduling, the people that have to go to the field, do they have the right thing? There was an example early on provided by my colleague Prasad on Cisco. And they were all, it was about service delivery and how they go to the warehouses to get the parts and stuff. So scheduling the people to get the right parts for fixing and asset issues and so forth, and survey. And these are some other common systems and information system that we see implemented at transportation organization that we can integrate with, as you can see from the list. In the world, there are multiple mega projects, and Gates will talk about the Saudi mega project. I think when you live in the Gulf countries, when you think about mega project, you think about the Kingdom mega project. That's for sure. You will list them. Now, if you kind of zoom out a little bit and look more at, also in the other continents, there are many happening in Europe. There is Rail Baltica. We'll talk about it. There is also, back in my home country, the Grand Paris. And even though we have a good network, good metro station and good metro network, but in the more rural areas, it's not that well, deserted. So we need to improve that network as well. We have also like complex highway. This is more like global, multiple places in the world. Railway fiber networks. There are many others that are mentioned, and there is also one in Germany that can't really pronounce the name, but Fehmarnbelt tunnels. So these are like big tunnels that they're trying to put out there. So let's talk about the Rail Baltica mega project. And some of those slides are courtesy of the Rail Baltica people that have done this project. You can see here, if you're not familiar too much with this, with the European continent, but these are all of the countries. This is a rail network, okay, at the high level. This is Poland here. You have the countries here, Latvia, Estonia, and Lithuania. These are all of the 3 countries where the Rail Baltica network is being implemented. And then you have Finland there. They have some rail, but it wasn't connected to Warsaw in Poland and to Finland. So they said, okay, there is that gap. We're going to put this brand new project there. Not easy, because how do you coordinate interconnected countries' rail network? They don't have just one contractor. They have multiple contractors. So they said what is very important for us is to be able to collaborate all together to make sure that we have a single view of all of the activities from planning, design, and then when the network will be implemented. So in terms of the construction, it began, you can see here, 2003. They have a plan to finish by 2028, 2030, so they are not there yet. They are in between the planning, design, and now implementing some parts of the network. So not everyone is at the same pace, depending on the land, right? Remember, I talked about land information system. That's the first information system they put in place, GIS-based, of course, to manage the land. Because the problem is, here, these are places where you may have different type of land, and some of it might have houses. Not everyone wants to have the rail network in their backyard, or maybe they are asked to sell their houses, or to sell their land, their piece of land, their parcels. So there's a lot of activities just related to land acquisition, and that's why a land information system is very important. Oftentimes we think just design straight away of the infrastructure. No, think land. Actually, not that long ago when we had some conversation with the Saudi Electric, that was also one of the main systems that they wanted to put in place themselves. Here you can see that in terms of mobility, it's not just for passengers. They are also looking at doing freight. Are you doing freight too? Or I'm not sure. Saudi Rail? Are you doing freight or passengers only? Both, huh? Okay, good. Yeah, so some of the requirements may change, and this is a fully electrified network. So they don't rely on the older tech of diesel and what have you. So, it has very specific requirements. And because if it's freight or passengers, they need to be able to have kind of a backup, rail network. I'm not too sure about the details, how it works, but that's kind of what I read not that long ago. The main thing is, they're looking at not only connecting all the countries, but reducing time travel, and this is all sustainability goals that are, behind all of this type of projects. Here, this is more zooming into the countries themselves, Estonia, Latvia, and Lithuania. Sorry for the rendering, is a bit, resolution is a bit low. But you can see that, for example, here we have like 4 main components, 4 segments of the network. Same thing here for Latvia, we have and then for Estonia. So multiple networks again, double tracks, and then, a lot of traffic that needs to be managed. And they're also trying to make sure that it's a seamless experience. So once they want to go to Finland, they are going to go to the place where there is the, kind of the port. I'm not too sure how it works, but I've taken ones from Denmark to Netherlands, Netherlands or Germany, I forgot. But the train arrives and the train goes on the boat. It was a very strange experience. I wasn't used to that. I'm used to, you go by car, you take the car on the boat, but the train itself, it was news to me. Interesting. All right, so what are they doing at Rail Baltica? These are the initial web maps. The rendering will be better for the next slide. This one is not showing too well. But these web maps, they can show all the information, consolidated information for corridor alignment, the land use, like I mentioned before, any environmental constraints, engineering data, and any type of stakeholder inputs like from the multiple countries. But it's not just the high level like network, how they are planning it and stuff, but also if you think about the environmental teams, they really need that type of information. So they share a lot through web maps, whether it's contractors, environmental teams, or even hydrological teams, but there are a lot of teams that are involved in there. So this slide shows how Rail Baltica uses GIS to ensure that design intelligence directly translate into construction efficiency and stakeholder alignment. And you can see here that during the design stage, Rail Baltica produced a lot of content. Some of it is in 2D, but also here you can see down more on the screen here on the left-hand side, the 3D data, the beam, the LiDAR, and the mesh. And this was mainly for all of the planning activities that they had. So you can see here also on this side, right-hand side, how do I share this to the public? So they had to really think about all of the activities and how they are leveraging this. And it's not just monitoring the construction and the progress of the construction, but thinking about all the stakeholders that are involved. They heavily use field maps as well as drone data for collecting all variety type of data in the field, and they do all this integration in ArcGIS to monitor the quality and the progress of the construction works. One thing also about monitoring the construction, they combine finance, planning, and construction projects. But what I like about what they do is that not only they provide the the progress of the construction, but they also provide that information more from a financial standpoint, for decision making. So they interact with the financial teams. And here, it's for the public. So depending on who are the users and who are the stakeholders, they have all the infrastructure, geospatial infrastructure, with all the data sets ready to then push the content according to the needs of those organizations. Here, this is showing, this is more the 3D representation. They combine BIM models, as you can see here, and 3D mesh, within the GIS, so they can show how the infrastructure fits into the real world and how, it will look like. You can see also the streets, the buildings, and all the landscape information. Now, this is another example in Europe. This is ProRail in the Netherlands. Actually, I have a video. I'm not sure about the internet connection, if we are connected here. Let's see if it works. Is it running? Not running here? Okay, it's okay. If we can come back to it later, let's move on. This one is the Italian railway and how they're using actually the BIM integration with ArcGIS. So let's see. This one. You can hear?
FS Italiana Group is one of the largest industrial companies in Italy. The group's main objectives are the implementation and maintenance of accessible, integrated, resilient, and interconnected rail and roads. Autodesk offers a suite of software and platforms that are able to connect the office as well as the field, and to ensure better collaboration and a seamless information flow. For us, the integration with BIM and GIS is essential. We integrated BIM and GIS to estimate the cut and fill volumes in a GIS environment around the tracks, or perform site accessibility studies for plants and equipment, to plan the logistics accordingly and minimize safety hazards and risks. Integrated BIM and GIS environments in a single platform allows different teams to communicate better. The group incorporated the protection of the environment into the strategy. We set up a workflow based on integration of Autodesk software to actively support the monitoring of environmental impacts, like Autodesk Construction Cloud, Esri ArcGIS, Revit, and GeoBIM. The possibility to automate repetitive tasks with embedded tools such as Dynamo facilitate around a 40% reduction of the time and make sure human error is minimized. Digital innovation will be the enabling factor for the potential of the group. The partnership between Esri and Autodesk is fundamental for FS technology.
So many organizations have a GIS strategy, a GIS vision, but they also have a BIM vision. And as part of the BIM vision, there is the integration with GIS. And it's very rare when you don't have that, because you can see from the example that was just shown here on the video, that they are really, really trying to bring all these data sets all together to have this single pane of view of all the information available at their fingertips. Here, this is another example from Italy. This is the RFI, Rete Ferroviaria Italia. I don't speak Italian, but this is RFI. As this. So they have actually a platform. They call it Station Land Platform. Okay, and it's a GIS system based on Esri that integrates various data sets, and that's demographics, business, tourism, etc., with every Italian train station. And they're really trying to to go at it by using this in a sustainable mobility way. So they have different hubs, and you can see here multiple screenshots of how they are using the GIS data, looking at the 3D representation like we saw before. Here there's no BIM here integrated in this screenshot, but you can see the 3D representation of the buildings and the train station. And then also here, this is more the multimodal connection according to the rail network. So some of the questions that they are asking themselves is, you know, like half of the Italian population works and live within a 10-minute bike ride of a station, maybe like 3 kilometers away. But how do you convince the people to go to it? So that's why they have, you know, the means to share that information. They do a lot of campaigns. They also do a lot of things to encourage people to take the train. I mean, when you're in Europe, you take the train. I think it's kind of something more of a habit. It's a cultural thing. But it also requires some effort to make sure people are aware of it. So here's another example now, moving on from rail to national highways. This example shows how national highways in England, here you can recognize from the map, they use ArcGIS Velocity, which is one of our products, to move from reactive incident management to real-time operational awareness. And here it ingests live data streams. You can see it includes traffic feeds, connected vehicles, third-party sources like Waze, as you can see from the notifications. They have Waze weather data, operational data, and they analyze this as the events are occurring. Okay, so this enables them to have the operation team able to identify incidents earlier, and then validate them faster, and of course coordinate response more effectively. So a very nice example from national highways here, how you can use ArcGIS Velocity. And you can, you know, taking all these real-time data feeds. This is another example from a port organization. This is Port of Rotterdam. I don't know if you've been following the news on what they do, but they started very early on, you know, really using ArcGIS, creating digital twins. But here, this is more showing how they use the real-time information where they combine live environmental data with forecasts to support, you know, safe, efficient port operation. So from navigation planning to berth and logistics coordination. So it provides here an up-to-date hydrometeorological information. So you can actually go on the website that is listed here at the bottom, and you can show all the information related to the weather and the tide. So it's only, you know, it's a one type of information that they provide. They do much more than this. When it comes to airports, there are a lot of trends. It's hard to just pick one. You will show, I guess, some examples. But I just wanted to show one that is a bit different. It's more like indoors. So this is the use case of Heathrow Airport. And then they use our platform to, with ArcGIS Indoors, to allow, you know, how to treat the terminal space as a strategic asset. That's really why they are using ArcGIS Indoors. And they want to make sure that everything is optimized, managed in real time, rather than static floor plan, if you wish, right? So that's, you know, of course, higher efficiency, but also better passenger experience. That's really what they're looking for, and a stronger return on their infrastructure itself. So here's the video. Let me make sure I play it.
Heathrow is a very vast world.
You can get overwhelmed by just everything that happens at Heathrow.
You have retail, you have security, you have baggage.
We're dealing with a huge amount of data and requests. We want to be able to do that in real time. There's a huge industry and a huge infrastructure that sits behind everything we do. So it's about how do we start to manage that from passengers arriving to passengers departing.
So using the legacy system that we had previously, it would take probably a good 2 hours to sort of get all that information on?
Our job was to start to look to see how we could bring all those systems together in a manageable format so that we knew the sort of spaces that we were managing and that we were dealing with across the airport.
Now using our new system, I can put something on within 5 minutes.
Single source of truth is really important to me because we have a number of teams that operate within the airport, all of whom have different requirements.
We've got 26,000 units across Heathrow and circa 4,000 property units, which is why it's integral that we have live data within our systems and dashboards. What Esri and Space Manager has allowed us to do is actually visualise that data.
There isn't a way we could go back to the old way of working. It doesn't fit with what we're trying to do going forward.
Previously, our systems have worked totally in silos, and as Heathrow is an ever-changing landscape, that can mean that the information, when it's put into a system, is already out of date.
Now we have SharePoint, we have Esri, we have Survey 123, so everybody can see what everybody is doing now and what the documents are.
Single version of the truth means that we've got the information that is on an agreement, which means that we can rely on that data and that information is accurate and it's correct. We're now fully understanding the impact that having an up-to-date GIS system can influence so much that we do within Heathrow.
Give me 5 minutes to let me show you what Space Manager does and you'll absolutely want to use it. The use of ArcGIS indoors has been invaluable to us to understand how we start to manage space. To be able to navigate round the maps as you're actually talking, it just saves so much time.
Okay, so I will just quickly finish on this. I mentioned early on that there are more and more sensors being put on all of the infrastructure, regardless of what it is for transportation. So there is really a need to also map out all of the utility networks, whether it's telecom or water or electricity and what have you. And as you know, we have the capability to do this. We have a flagship product called Utility Network that can help you to do that. I'd just like to also mention that in Germany, in April, we have our international Esri conference for infrastructure, and in transportation is a big part of it as well. So I invite you to take a note of it, and hopefully you can join the community there. Now I'll hand over to Keith.
Thank you very much, Christophe. A very great presentation. I think people, you can hear me now, right? Okay, so for the people who just joined recently, my name is Geo-Enabled Sahib, and I lead the transportation and logistics sector at Esri, Saudi Arabia. So today we're going to talk about, the challenges, as my colleague Christelle mentioned, with respect to the transportation and how they are affecting the transportation in general. Across the kingdom, driven by Vision 2030, the transportation sector is transforming rapidly. It's growing demand and increasing expectations of safety and sustainability. Unfortunately, organizations today, they deal with congestion, which is traffic jam, fragmented data systems, and the need to take faster and smarter decisions. The transportation is not broken because, we lack roads or airports or seaports or infrastructure. It's actually broken because we lack connectivity, visibility, and intelligence. So let me walk you quickly through today's agenda, where I will start talking about the global transportation challenges that we face and how it's reshaping the transportation sector globally. Then afterwards, we're going to dig deeper and look at the Saudi region and why the region here is quite complex, however unique, and how GIS can help us overcome those challenges. And before we go with the key takeaways and closing, we're going to mention some of the use cases that GIS can be implemented and has been implemented in certain areas like seaports, airports, and also other examples. So let's start by talking about the global transportation challenges and how they are reshaping the future of transportation. The first one that I think we can all agree on is congestion, which is basically traffic jam. So right now the demand is quite high. However, the capacity is not meeting the need of the enormous number of cars that are appearing, and also the buses and the taxi and the different transportation modes. So this is a very crucial one. The second one is the siloed systems. So basically systems right now, they don't connect with each other in the same organization. So sometimes I'm gonna talk more about that in details in the coming slides. Some organizations, they don't connect with other organizations. The financial team, they don't know what's happening on the field. Also the field, don't know what's happening with the financial team and what's happening also with the leadership. So this is something that's extremely important. The other challenge that we face is the limited asset visibility. Nowadays, customers, businesses, they want and they need to know where their assets are. So just saying the asset has left and it's in transit, it's not enough anymore. Consumers either would like to know when they're going to receive the packages so they can be present and available. Businesses also, they would like to track their parcels and shipments so they can see if it's arriving on time, if it's in the right temperature, it's in the right conditions. So this is a very important thing. And last but not least, of course, the safety and sustainability. Right now, businesses, they're not only measured by how much money they make, it's also measured by how safe and green they are. Those basically the challenges across any country and transport mode you will face. You cannot escape them. So let's talk a little bit about the traffic jam. I'm going to show you a number, but before showing you a number, do you think we spend more than 100 hours on the roads due to traffic or less? Just raise your hand if you think it's more. More than 100 hours per year. Okay. Excellent. So the number that I'm going to show you right now, unfortunately, does not meet your expectations. So it's around 52 hours. However, I don't believe that this number is correct. But I put it because it's based on an official source. So almost people lose around 2 full working days just sitting in traffic. So it's not sitting in meetings or sending emails, just sitting in traffic. I can see people are smiling and are relating to that. So this is, huh? Exactly, this is only for 1 month. It can even be much more, but you know, due to the sources, I put that. But this is a very important and a very challenge that we face at the market, because also we lose a lot of fuel. This is also affects, you know, the psychology, the well-being. In addition to that, it also affects the pollution as well, because we spend much more time on that. The second one is siloed systems. So basically, as I mentioned, in organizations, the different departments inside the organizations, especially in logistics center, they don't communicate with each other. So let's have a quick example in any logistics company where you have the TMS, the traffic management system. In addition to that, you have the warehouse management system. So the traffic system, they don't know what is the inventory in the warehouse system. And the warehouse management system, they don't know where other shipments are going on. In addition to that, the leadership team, they only know about the complaint or the issue once the customer raises the complaint. So this results in 2 important things. The first one is high operational costs and unhappy customers. And I don't think any business wants to have that. The second one is that we spoke about the limited asset visibility. Believe it or not, almost 70% of logistics company and delivery services companies said that their main obstacle is they don't know where their assets are. This number is quite huge, or this percentage is quite huge. And this problem, if it's not solved, is going to cost the logistics companies a lot of issues. We are talking about, you know, reviews from customers, customer satisfaction, in addition to that, the expected revenue. Now, another unpleasant percentage is that customers, they stop buying, 33% of the customers, they stop buying only from experiencing one poor delivery. I think all of us in the room, we have experienced this in a certain time. You are expecting your package to arrive within 1 hour, then suddenly you receive a message. Unfortunately, the delivery time and day have been changed. And this is also a very important thing. Imagine losing 1/3 of an expected revenue just due to one poor delivery experience from customers. The third one and the most important one is, or I would not say it's the most important one, it's one of the most important things, is safety and sustainability. Of course, it's the most important one when it comes to safety. However, sustainability is also a very important topic right now. Companies, they are not measured only by how much money they make, but also how safe they are and how green they are as well. So, we have spoken about some of the challenges that we face. Right now, we're going to talk a little bit about the Vision 2030. So Vision 2030, it's not a slogan anymore. It's a transportation blueprint. With all those mega projects that are happening, we need to focus on the transportation sectors because, people are going to judge by how, seamless the moving from a point to a point. In addition to that, when they drive to the airport, how the airport experience is. Are they going to find, congestion? Are they going to stand in queues? So this is a very important KPI to be achieved in 2030. Right now, I'm going to show you some of the mega projects and the giga projects that we have. I think we all know that we have a lot of big giga and mega projects. However, I just thought to mention and highlight on some of them. The first one is the Red Sea Global. And I'm sure that we all have heard about this important project. So a lot of luxurious hotels and resorts are being, built at the moment and also being planned to be built in the future in more than 90 islands in the country. So this is a very big project. This means that safety should be taken into consideration, cost should be taken into consideration, planning, having a good infrastructure for this project. In addition to that, Riyadh Metro, and we have our colleagues from SAR, at the moment around 3.6 million passengers are being handled daily by that. This is a huge number, and it's expected to double in the coming years. So without having the proper planning, this is going to cause a lot of issue. Last but not least is, of course, the famous World Cup in 2034. And this needs a lot of crowd management. In addition to that, you need to have the right infrastructure because you're going to transfer crowds, you're going to have hotels going from in and out, airports, all of that. So those examples tell us that without having the proper infrastructure and the transportation solutions to transfer goods and also construction materials, let alone the consumers and the customers themselves, this is going to create a lot of challenges. So now we have spoken about the mega projects. Let's talk a little bit about some of specific use cases that are related to Vision 2030. One of them is basically seaports. So right now, KSA is not going to be only a regional hub. It's planning to be a global hub. Almost 13% of the global trade goes through the Red Sea. And not only that, at the moment, the seaports, they handle around 20 equivalent units per year, which means 20-foot containers. It's planned to be 4 times more by 2030. This is not a regular growth. This is a system shock. And if this not being planned and prepared in advance, is going to cause a lot of challenges. The second one is smart mobility. So before we talk about smart mobility, we hear a lot of smart cities, smart mobility, but what is smart mobility basically? Smart mobility is the connectivity of data with assets and intelligence. So if I want to move from point A to point B, you need to have all the right transportation modes, you need to have all the data, all the information, in order to guarantee yourself a seamless transportation. What I found to be interesting is that almost 78% of Saudis are willing to use smart mobility. However, only 6% are doing that at the moment. This tells us a very important message, that people are ready to use, however the systems are still not ready. So this is also another important thing that we should take into consideration in the region. Now, why GIS is important to overcome those challenges and help us get over some of the problems that we face. The first one is spatial data integration. So instead of just seeing the package leaving from a certain warehouse and you wait until it's being delivered and you don't see it like on a certain map, just on Excel sheets, it gives you the real spatial context where you see where your asset is exactly are. In addition to that, you can also do a real-time traffic. So every second you want to check where your assets are, you know. If you want to check also what conditions your assets are, like if you are transporting pharmaceutical, for example, or some sensitive material, you can also know and track them very well. This results into a very important goal, which is to have a unified picture. So instead of communicating separately with certain people saying, okay, where is my package? Or did the package arrive? Is the customer happy? No, you can have a very full picture and you can see everything that is happening in front of you. And this results into a very important thing. So it results into better ROI and better decisions. So you improve your ROI. This is something that all businesses want to do by making better decisions. So let me talk quickly about the airports and some of the challenges that we face at the moment. The first one that we all know is passenger congestion or passenger optimization flow. So if you're having 5 airports that are arriving at a certain time, you need to be aware in advance so you can have the right, security and passport control, the ground services, how to handle the packages, the gates, also the taxis outside. So this is a very important thing. The second thing is the air side and land side coordination. So this is also an important thing for airports. Without having this coordination, it will create chaos. I mean, I'm pretty sure that some of us have experience where the plane just landed and we stayed inside the plane for more than an hour or 2 hours. This is one of the issues that GIS can help us overcome. Emergency, I know that at airports, emergency usually very rarely happens. However, if it happens, it's catastrophic. And this can prevent a lot of things through ingesting different data like weather conditions, the condition of the airports, the availability of the staff. So by having the related information being spread on an ArcGIS, on a GIS platform, it will help you overcome some of the challenges. So now let me show you a very quick video of GIS application at San Francisco Airport. The original video is around 13 minutes, but I was able to crop it to 53 seconds, just to show you how they implemented the GIS and how they improved the operations there and also the safety as well.
Case study at San Francisco International Airport, we revealed the complete operational schematics. We systematically mapped artificial lighting placement across terminals, airfield positioning, inbound and outbound traffic, passenger flow through security and gates. From a schematic point of view, we unified all departments into one platform. Cross-sections revealed real-time density, movement patterns, bottleneck identification. We monitored environmental controls, temperature management. The overview showed aircraft positions, taxiway movements, departure speeds, gate assignments. We can implement the same system across Saudi Arabia's transportation network. This is how Saudi Arabia transforms complexity into clarity. One platform, total intelligence, clear results.
Okay, cool. So this is only just a small fraction of what can be implemented. And of course, afterwards, after the session, we can talk more in details about that. So, last mile. Last mile is the last leg of delivery for any package or parcel. So once you do an order via different applications, and you see that the packet is leaving a restaurant or a warehouse and it's coming to your place or your work where you live, this is what we call the last mile. And this is where customers basically judge. 10% of the customer only remember the last journey. So they don't care about what happened at the beginning. They don't care about the first mile or the mid mile. What they only care is that when I'm going to receive my package. And this is a very important thing. And here in the last mile, promises are either kept or broken. So this is also a very important thing that we need to consider. GIS and seaports. Now, as I mentioned, there is a huge KPI in 2030 to increase the level of transportation, goods, and also people. One of the things that GIS can help is the berth and yard optimization. So basically, in Arabic, الرصيف البحري والساحات. Once the ships come and they need, to just dock and take and evacuate the containers, this is a very important thing in the seaports, and with having the GIS, it can give you a very good planning and prediction. The second thing is security. We spoke about it, but also the same concept. And the third one is the logistics integration. So when the ships arrive, you need to know, are we ready? Do we have the right workforce? Do we have the trucks? Do we have, the right warehouses in order to be able to take the containers, evacuate them, and afterwards put them in the transportation trip? I'm going to show you a quick video that has been done by Port Coast in Vietnam and how they used GIS and how they were able to optimize and better plan their airport, the seaport, sorry.
In the Vietnam case study, we used LiDAR surveying technology to map out the landscape, environment, and the height and relevance of the area. We also mapped the entire port operations. Real-time container tracking allowed us to recognize the number of blocks in the area. The container tracking system also monitored temperature, container counts, and how fast they moved. Digital twin modeling captured shipment positioning, container availability, and environmental impacts, such as transportation flow from the port to the city. A complete terminal management unified platform was achieved, and this system can be integrated into Saudi Arabia's port authorities around Dammam, Jeddah, and Jubail. This is how Saudi Arabia transforms complexity into clarity. One platform, total intelligence, clear results.
Okay, this is basically, the slide before the last one, and this is actually the desired end state that we are planning to do, is to integrate all different transport models into one platform. So you can see the seaports, the airports, the planes are arriving at a certain time, then they are connecting to the buses. So if you have 10 planes that are arriving between 8 and 5, just need to make sure that the railways, the buses, the taxis are available to accommodate those customers. In addition to that, like if you want to travel to a certain city within the kingdom and you have an alternative like using a railway or using a ferry, this also can be an option. So this is the desired end state that we are looking for here when it comes to the transportation. So from fragmented networks to one orchestrated system. So GIS is not only about mapping. Previously we had this kind of conception. Now it's about mapping movement, and it's about orchestrating national mobility in real time. So this was basically my presentation, so thank you very much for listening, and afterwards I'm going to introduce my guest, Fahad Al-Sanad. Thank you very much.
Assalamu alaikum jami'an. Hello everyone. I am Fahad Al-Sanad. I am a representative of Saudi Railway. I work with the engineering department, especially in the data team. So today I want to talk a little bit about our topics, such as GIS and IBM Maximo integration. And the other one, it will be the land bridge, أو الجسر البري. So first of all, thank you. First of all, we need to understand our business needs. But before asking ourselves that questions, we need to understand our scale, our network scale. Could you please raise? So, at Saudi Arabia Railway, we have a railway that extends over 2,000 kilometers, and it can get up to more than 4,000 kilometers if we included freight lines and railway doubling. With the help of GIS Survey 123, since we have more than 4,000 kilometers network, our assets could be spread across different regions and environments. And with the help of Survey 123, it helps our maintenance team to inspect and the exact location and extract the exact location and inspection throughout GIS Survey 123. This slide shows our IBM Maximo recent 2 years, 2024 and 2025 work orders that we have extracted from IBM Maximo, which we have more than 231 work orders. Most of the work orders, as you can see here, 75% of it was preventive maintenance, and 25% of it was corrective maintenance. And we have successfully closed 98% of the work status. So before we dive into the real charts and the real shifting points, I just want to remind you that every authority or every company here at Saudi Arabia deals with a lot of problems with integration between two systems. And I can confirm you and assure you that it cannot be any harder. As this slide shows, IBM Maximo integration in 2024, before integrating it with GIS, we had almost or nearly 100,000 work orders. 71,000 was preventive maintenance and 28,000 was corrective maintenance. But what is really important here to focus on the average duration. And once we jump in to the next slide, we will show you that it's now in 2025, even though the total work orders has increased by more than 30,000 work orders, we still have average duration less than previous year, 2024, with 120 minutes has been saved. So, in the next slide, I will translate these numbers into real KPIs. As we can see, if you could please, the next slide. For the cost, it has been reduced by 20%, and for the time it has been reduced by 33%. And for efficiency and accessibility, intelligence and safety, all of them has been increased by a lot. But since we are speaking about GIS, it's really important to integrate these systems with each other, especially with other governmental systems and authorities, such as Ministry of Transport and General Authority of Survey. Here it bridges us to the GIS and land bridge. Before starting, the land bridge aims to connect the Red Sea to the Arabian Gulf through Yumbu and Jeddah and Riyadh all the way through Dammam. There are two main points here in land bridge: is establishment of new lines and upgradation of the existing railway network. The new lines, which is Riyadh to Jeddah, which exceeded over 1,000 kilometers, and Jeddah to Yumbu, which are almost 340 kilometers. And the upgradation, it will work for Riyadh to Jeddah to Jubail with over 600 kilometers. The Saudi land bridge project is approximately around 1,300 kilometers, and we have segmented them into many segments. As we can see, JIL, Jeddah Internal Link, is about 70 kilometers, and Jeddah to Riyadh West Link is approximately 350, and so on. We have been breaking them to segments to ensure that successful integration of our future GIS data that is coming from the land bridge is fully integrated with our current one that we are using at Saudi Arabia Railway. Of course, many of you have been working with GIS and especially with the new projects, and we all deal with the new projects whenever we receive new files or new data. We all find they are different type, different scale, and different projection, such as KMZ files, geodatabase, and Excel sheets, and so on. But with the help of GIS, it can be used as a container to collect all of these different types of files, such as we said, KMZ or geodatabase, CAD files, Excel sheets, to use them simultaneously with only one unified system, which is ArcGIS. A really important note: stakeholders share a major point with the transport network in general, such as if we are talking about the land bridge, like often we will intersect with Ministry of Energy or any authority similar to it. With the help of coordinates and GIS, it helped us a lot and make it much faster rate than previously, like speaking maybe more than 10 to 15 years ago. Next slide. Thank you so much for your time. I am Fahad Al-Sanad, and I was glad to share you. Thank you.
Great presentation. Thank you very much, Fahad. So it's questions time. Does anyone have any question, any comment? We are very happy to answer. Everything's clear?
Thank you so much. This was really good presentation, what you shared. I wish I could see the actual system. Right? One day, inshallah, we can do that. What I like is how you presented, the KPIs. Oftentimes, organizations are not able to reach that level of sharing this. How did you measure those KPIs improvement? You mentioned, the work orders, those numbers, that's kind of easy, but you were able to measure the efficiency and others. So how did you do that?
Yeah, sure. So, since we are using IBM Maximo, that's mainly focusing on maintenance. So whenever you have a task order that you have completed, you can already check with the Maximo, IBM Maximo website or system, whenever the maintenance team has fully maintained the asset, he can check it on the system. Whenever it has been checked, we can already check later on what was the duration, was it executed very well or not. And by this, we can reach to our KPIs. Thank you. Any more questions?
Yeah. Any more questions? Sorry, Andak?
Okay. First of all, thank you for the great session. I'm Mohammed Abdrabou, GIS System Architect in Road General Authority. My question for this slide, for ArcGIS velocity.
ArcGIS velocity.
Yes.
Samin? Okay. Sami? Okay.
Can you hear?
ممتاز الآن يعني صوتي هو صوته المشكلة مش صوتي أنا.
For the slide of ArcGIS velocity, how data ingested into ArcGIS velocity from regular cars? يعني, as per my understanding that this car is for residents, car in the me and you and for everyone. How this data ingested into ArcGIS velocity?
Can I show you the picture? Oh, you already know. This one. It's the plot data.
Yeah. So the phone in the car itself, that's what they were using. Yes. So that's why, like, for example, from the Waze application. So any application that would, have, yes, from the phone. From Waze, for example. Yes. Yeah.
Okay.
The main challenge which we have here in organization in Saudi Arabia is the updating of road network, as you know. You hear?
Yeah.
The main challenge which we are facing in Saudi here in our organization is the transportation road network from day to day, as you know. So do you have any updated solutions in the AI world which is solving this challenge here in the kingdom as a use case, or any suggested solution to deal with this challenge?
Okay, I'm not sure. Have you heard the question? Okay, excellent. So with respect, to the challenges in transportation network, if I understood your
updating, yes. The updating.
The updating?
Exactly, from day to day. When you have a new bridge, a new tunnel.
On the map, you mean?
Exactly, and the collaboration between...
Yes, yeah, this is a very good and a very important question. So basically, we are currently working with partners where they are doing collection almost on daily basis. So there are some changes in roads or some changes in the point of interest, like restaurants, or the changes like, for example, that the road was one way, then it became two ways. So we're already working with different map providers and also different, let's say, data providers in order to improve that. I actually was having a meeting today with one of our partners, and we mentioned that to them, and they have a very strong plan in order to do these updates. But it depends on which map that you use. It depends on which, I don't want to mention the brands, but yeah. So I can tell you with the partners that we work with, and also with some of the government entities that we work with, we are planning, to have at least an 80 or 90% accuracy of the map, because you can never have a 100% accurate map because changes keep happening every single day. So yeah. And I think this question should be going to the Ministry of Transportation and Logistics or Road General Authority, but I can tell you from the private business perspective.
Welcome everyone. This is a session focused on AEC. The session is specifically focused on how GIS is the foundation for modern AEC workflows. By AEC, I mean obviously architecture, engineering, and construction practices. And the focus is on how location is the common thread that connects things like planning, design, construction, and operations all together. Across the AEC cycle, teams struggle usually with fragmented data, with siloed data, and the idea here is using GIS as that big container that brings things together, but not just a container, but also a set of capabilities that helps people create tailored and catered templates that serve all the side of the life cycle of an AEC. Okay, so the focus today is going to be on how we view AEC as Esri, and how we develop our products, how we develop our systems, our workflows in order to kind of go within that cycle. But also, we're going to talk about so many examples from around the world with an idea on what did they do and what was the value of bringing GIS into AEC projects. So I would really appreciate your quick feedback on the app. If you have the event on the app, please make sure or to make some time to kind of go into the survey and fill in your feedback, what you were hoping to hear about, and what you actually heard about, maybe, and any other recommendations that will help us make this content a bit more useful and targeted in the future. So, to support growth, we really need to enhance the digital and business transformation in the AEC industries by location analytics and to maximize the money we spend and the budget we put for the likes of ArcGIS as a platform. This enables projects to be executed sustainably, equitably, resiliently, and supports the creation of new industry-specific solutions and workflows that help us cater for the different parts of the life cycle of an AEC, from from surveying to design to construction and to delivery and digital project delivery. Again, infrastructure, it operates in a geographic context. That's by default. This is how it is. It's shaped by the surroundings and the interdependencies between the different aspects within the environment. GIS connects built environment, society, and natural world. GIS also helps us do things like manage roads, utilities, buildings more effectively. So it's not just the construction side of things, but it's also the post-construction element to do with the maintenance of the assets and how we work with them. This ensures that we keep the communities in touch with the actual data that was done in inception when we started building things, and make sure that GIS is managed properly within a city, within a municipality, within a planning council, and so forth. So quickly, and if you haven't been to one of our sessions before in the AEC side of things, we as Esri we view the AEC cycle, or modern cycle of AEC, as follows. It basically incorporates things like field and reality and real-time sort of analysis and monitoring, and it leverages so many applications that support the data collection aspect of the project, so the initial kind of survey side of things, but also environmental and urban planning and engineering design, connecting information across different systems that have their own system of record, they have their own assets, they have their own real-time data, and so forth, making sure that it kind of brings teams together to collaborate, but also supporting visualizing and simulating all these things that are collected, and analyzing the data after it's been collected. That helps communicate all this complex information in an easy way that is easily visual, but also easily interpreted in using GIS. But this ultimately brings you to the field to finish through the project management side of things, and using integrations with things like project delivery platforms and project management platforms. It helps, and ArcGIS GeoBIM, it helps you get this construction site very, very focused and very enabled with the geospatial information that it has at hand. We had a session just before that talking about construction management specifically, and that focused on that project management and delivery side of things, and a bit of the reality capture element. In this session, I'll be covering the whole life cycle from all different aspects, and how GIS kind of brings all these areas together. In reality, infrastructure and buildings are complicated things to plan and to design and to build and operate. But at the core of it is location, and location is obviously the center to making this life cycle information successful. Now, GIS supports AEC firms in 3 business areas. This is how we view it when it comes to AEC companies. So with AEC companies specifically, if you're a company working with local authorities, your view would be, well, I want to win work with planning organizations, with projects such as lots of where you guys come from. But those AEC companies, so many of them, big scale, small scale, some of them work in urban planning, some of them work in design, some of them work in construction. They all want to win work, and usually to help them, GIS helps them demonstrate their ideas, demonstrate what they want to deliver in a good way that is relatable to people, and that's using GIS. It's the perfect tool for doing that kind of thing. Now, in terms of doing the work, so again, projects, people that are coming from the project side of things, who work for big organizations that implement projects and bring these subcontractors to work with them, or the subcontractors themselves, doing the work itself, GIS enables that side of things, which is doing lots of things from site selection to urban planning to environmental assessments, BIM integrations, reality mapping, and so forth. And this kind of streamlines all the process of from conception to delivery in the end. But then the actual, after everything is built, the third part where GIS kind of plays a lot in this area is running the actual business, which it basically boosts staff efficiency because you have all the information at hand, you're in the field, you have the information in an app that's catered specifically for you, doesn't have a lot of information, just has an information that relates to whatever you're doing in the field. It also accelerates the collection of data in the field. If the app that you have collects the data, it also enables design teams to get the reviews quickly. It enables the owners to kind of receive information in a very streamlined way and assess it, and even automate assessing designs and things that have been submitted by subcontractors. We see that in a few slides. Now, small fact. In the engineering and construction sector, there's a lot of progress that happened in the past years in the digital side of things, but that's because there are so many inefficiencies in the system. Now, as much as that's a real statistic, is as much as 30% of all building materials delivered to a typical construction site end up as waste, and that's equivalent again to throwing 1 building every 4 buildings. Obviously, the amount is staggering because of inefficiencies. That's not just inefficiencies of the planning side of things, or organizing the material and having a good bill of quantities of assets, physical assets that go into the site, but it's also because we just don't have this kind of end-to-end kind of process that kind of optimizes and constantly updates the type of information and type of assets, the quantities and things that need to be at a specific point in time at specific location. Now, beyond, again, the material use material waste and misuse, there are around 90% of projects are delivered late, and we see that every day. If you're an engineer, you come from an engineering background, you always know that there are always delays. 40% of job sites work is unproductive, and 40% of buildings are underutilized as well. Now, we want to move towards a bit more of a sustainable world. There are sustainability matrices and things that are in place now to kind of measure that for us. GIS enables that measurement, but enables us as well to do our job better in order to reflect that in the way we are sustainable towards the environment we're building in. Now, we see 3 core challenges. First of all, disconnected data, which is, I reckon you've heard that in many, many talks, that GIS kind of brings different departments together. That is very true, and specifically in the project side of things, because you speak to anyone who works in projects, and lots of times, 90% of people would say, like, oh, I know about that GIS thing, but don't really know what it does. There's only 10% of people probably that work and utilize GIS every day on a project. And that's very true because GIS is sort of an infrastructure thing. It's something in the background. It doesn't need to be seen or touched constantly, but it brings this whole environment together. The second challenge we see is the rising complexity of projects. So projects are now like, let's build the tallest or biggest or fattest or deepest, or they're all the adverbs that you can use. And this makes projects complex, very complex. It drives kind of so many engineering, architectural challenges, civil challenges that go into site. So in the midst of all that, and with things that change constantly, because you're doing this thing for the first time, I'm building a tallest building for the first time. So there are things that constantly change. It's not a thing that you constantly keep on building and replicating, and you have just the same set of problems constantly. Things change all the time, and these delays and these things need to be communicated right away. And GIS facilitates that part because it's geographical, so it kind of helps all those teams to kind of communicate changes and changes to kind of take place from one place to the other very fast. That's a very important point. The third part is the, again, lack of location awareness. Typical. I don't need to maybe talk about this a lot, but again, the lack of understanding of geography makes all the difference within a project side of things and enables you to look at risks. I'm going to focus a little bit on this coming part on Esri's focus on AEC as an industry specifically, and where we kind of put our money, we put our investments, we kind of where we think the major problems and major applications and workflows are within this whole kind of life cycle. So AEC sector focuses supporting, again, commercial firms delivering products, but also owners and running their own projects in these kind of 4 domains. Environmental consulting, so doing things like impact assessments, compliance and sustainability. Architecture and urban design, so again, from planning to geodesign to landscape and buildings. The engineering consulting side of things, so covering civil, environmental, infrastructure, enterprise. Construction, both horizontal and vertical, in both dimensions, through the project handover to the communication side of things post handover. And underlying beyond those are obviously the ESG commitments, so all sustainability, environment, social, corporate governance, kind of underline all these kind of aspects or pillars as we see them as we go within a project. I'll start with the first one, and apologies, I've left a random word there. GIS and environmental consulting as a practice is kind of brings environmental consultants together to deal with this siloed data in order to address things like complex regulations, long project timelines, integration challenges, all while making sure that digital delivery is also running in parallel. So you're not pausing and saying like, hang on, everyone, stop building. Now let's go back and start realizing and seeing and measuring the impact I have on my environment. It's something that needs to be going in parallel, not interfering with project delivery, with the digital delivery that's happening in parallel. It needs to happen seamlessly as we go in the project. So our focus here was basically trying to streamline the data collection, processing, and reporting, and the tools that we kind of try to kind of put in place were to support regulatory compliance, improve collaboration, and deliver again engaging, information-rich type of data that kind of can be put into apps and actually measure certain metrics that are put in hand that kind of provide to kind of monitor on live dashboards, on project reports, in order to kind of keep in line with our environmental impacts on the environment we have. Now, looking at the technology itself, I mean, you probably saw that maybe in one of the sessions before. We put so many tools and capabilities within our platform. This is again an example of setting different sensors on the facades of a building in order to capture sunlight, and capturing sunlight, calculating the impact of that on the structure, calculating the impact of that on things where you could install possibly solar panels, where you could see consumption of energy increases and decreasing, and that's all bringing together 3D space into action to kind of analyze. Another thing is here's some work done by Airflow Analyst, one of our partners, that kind of simulates winds and certain different variations of winds within an environment and see the impact of the 3D built environment on where those builds are going to go. So you can put your designs and start running wind simulations and understanding how, with the strong winds that come from certain directions, could affect how your buildings could affect that wind flow within your urban canyons. And that kind of goes with, you can metrify that as well, calculate that within your structures, your 3D structures, and see the impact of wind movement and wind flow. Other capabilities are like flood analysis as well, and understanding again why if we get a flood not just from generated by rain, but if it comes in from sea, and the impact of that on certain certain neighborhoods. Now think about that. Think about that in the context of having a built environment, having an environment that has a 3D element to it. You have BIM models can be thrown in the mix as well, where you can understand like at a specific precipitation level, a specific water level. There are certain 90% of all my metal steel foundation bits are going to be affected. So you need to understand and metrify, put these things into numbers in order to quantify the amount of risk you have at hand with different designs. Now with ArcGIS, environmental impact assessments can move from static reports to fully digital interactive experiences. Again, this is all using out-of-the-box tools, no coding required here. They're dashboards that kind of can be built very easily. Spatial data, design information, and dashboards, and even real-time metrics can be thrown together into story map, instant apps, and experience builder from day one since you kickstart the project. The result, again, is a digital EIA, environmental impact assessment. So it's a digital one. It's digitally live as well that you can use. It saves time and cost. It improves efficiency, delivers better transparency and engagement for all stakeholders that are instantly walk into the project and want to understand like, yeah, that's fine, we're building that much. What's my environmental impact metrics at the moment, and what do I stand? Am I conformant, non-conformant, and so forth? And obviously enables you in the field as well while you're in the project to kind of take decisions right away and rectify situations as they go. This is an example from the UK on the HS2, so high-speed rail project in the UK, across the UK from the north to the south. It's a big program. Now Kumba's group, basically they needed a transparent real-time way to manage ecology, also mitigation and mitigation of vegetation and things that are in the route for that rail. And it's such a complex rail project as well because it's on an environment that has so many things in the place. So one of our distributors, Esri UK in that case, they have a small tool that's built on top of the platform that's called the Suite for ArcGIS, Suite as in sugar sweet, and it's basically it created a field to office kind of type of GIS, type of workflow that basically helps capture things in the field and send them straight away to the GIS using not Survey 123, but it's custom catered for those type of long projects. Long-range projects, and it provided teams and clients with real-time visibility, and as you can see, the dashboards to ecological constraints and progress, which enabled, again, faster decisions and, again, compliance to legislations and things of that sort very quickly in the field. Another example here is Oricon. So they basically, that's an example from Australia. They used GIS to, again, move environmental assessments beyond delivering PDFs and reports, but they've created, taken that data, they've created interactive maps, 3D scenes, videos as well of things that people capture in the field, and links to that, and basically rich media all around those things with the metrics assigned to it as well. So it's a bit more progressive in the sense that how to visualize these things and present them to the public and the stakeholders as well than HS2 in the UK, for instance. And by presenting all this, it kind of strengthens, again, the collaboration between different teams. Different teams now know the impact of the planning, the design, as they go ad hoc during the project lifetime. Another example here, similar example as well, again back to the UK, on the motorways in the UK, which is the highways. Of M60, the motorway 60, M62 and M66 Sinister Island interchange projects, and that project was run by Jacobs. Now the idea was that it's a nationally significant project to kind of maintain that highway, upgrade it because it's been run down for years. And upgrade, obviously, there things take a bit longer than they do in places like Saudi Arabia, for instance. But over that amount of time, they want to see the impact or the environmental impact that during those different phases of the project that it took on the on things such as noise and vibration, ground conditions, geology, ecology, air quality, and water. So traditionally, these things again were done using PDFs again, and reports that have been compiled every specific timeline. They've done that by bringing. They had all the GIS, and they realized, well, we could just automate that and digitalize it, which is what they've done, delivering all these metrics, so noise, vibration, water, ecology, birds, habitat, everything around in the same way. So this kind of helped very much. Again, those three examples specifically talk to the same. They have the same story. This is a pattern, as you can see. It's things that are reports. You need reports eventually because you need to document things at certain time slice, a certain time within the project timeline. But those are kind of live things that bring teams that are working on the ground now on the project and need to monitor these things as they go. And this is an example here closer to the city we're in, so Riyadh Infrastructure Projects Center, or RIPC. So for the Riyadh's infrastructure projects, the GIS was used to integrate environmental data directly into planning and delivery decisions, making sure that the alignment with the projects are being done in alignment with Vision 2030 sustainability goals. ArcGIS enabled people like planners and engineers to assess land suitability, ecological constraints, and also construction impacts on the 3D environment and the surrounding of it over time as they build them, rather than a static again reports that are being delivered. Again, this approach reduced things like inefficiencies, calculations that and things that could have not been delivered in time, and again making the urban development side of things very, very risk aware. Obviously, as you can see, some of those projects involve so many big organizations that work on them, like Dar Handasa here, EXP, Parsons, and others that work on those projects, and they all come together. They're not just one organization that is siloed. You have this kind of consortium of organizations that work with each other. They all have planning departments. They all have survey departments, some to a certain maturity and so forth. So it's just multiplying the complexity of how people deal with each other. But if you have the one source of truth at the owner level, those subcontractors, those companies come and work into your ecosystem, and they make sure that everything's aligned with your and streamlined with your digital baseline, rather than having having Parsons, hypothetically speaking, coming in, building their own thing and delivering something, and then you start to try to tweak it to kind of fit into your bigger digital strategy. Start with strategy first. Another project here in Egypt, Ras Al Hikma, north of Egypt and the north coast, the Mediterranean, where GIS was used to coordinate, is being used now to coordinate a large-scale coastal smart city being developed in collaboration with Modern Properties. Modern is a use organization in master developer in Abu Dhabi. So with that, they try to align all the planning and the designing element that is going now in place, because the project is at the beginning, at the start of it, and they already started building parts of it. And obviously, another thing is the sustainability element, because it's all by the beach. There's a lot of measurements on where the shoreline is and where it's likely to kind of recede and move, and the impact on the habitat as well under the sea. But then ArcGIS also embedded spatial land use analysis, BIM and GIS integrations as well, 3D master plan visualizations, and trying to help consultants such as KEO, for example, and Dar Handasa and others to evaluate scenarios and infrastructure replacement in context of that. So the idea is that they're trying to do it right from the beginning, rather than trying to build stuff and then trying to rectify things as they go. Another example here is of the Red Sea. I have my colleague here, Hisham Ghaffar, whom you might know very well if you work in Saudi Arabia. He obviously works with so many of those kind of big organizations. Hisham, do you wanna take this one on Red Sea Global?
Thank you. Can you hear me? Okay, so Red Sea, I think you all have heard about Red Sea, and what's unique about Red Sea that they need to take care of multi-dimensions project, because it's not just about construction or design or building a new coastal city. As well, they are trying to utilize the power of visualization within ArcGIS to build a tourism destination, a coastal, luxurious tourism destination. RSG have been always an active organization when it comes to GIS and BIM interoperability. They have utilized the power of interoperability within ArcGIS system to integrate with multiple data sources. And of course, when it comes to AEC projects, on the top of them comes the BIM formats. As well, what makes this project kind of unique, that they need to take care of the environmental aspect of the project. So they have utilized the ArcGIS and ArcGIS dashboards to monitor the impact of the construction work on the water quality on the coast of the Red Sea. And this, as you can see here, that this helped to in achieving 30% faster environmental approvals with GIS data. As well, when it comes to integrating the BIM and GIS, and you all know about the hassle of integrating both data formats, it helped to reduce the design errors when it comes to these two worlds integration. And of course, we're talking about design, construction, and environmental aspect. This helped a lot when it comes to enhancing the sustainability and achieving the sustainability goals. And by the end of the day, it's a mixed goals project: tourism, sustainability, and of course, construction.
Yeah, and I think the also the one point here is that they actually went through the hassle and the burden to kind of calculate how much have they saved on on some of those processes, because this is important. Again, if it doesn't make sense, don't do it. Simple as that. You're all operational. You need to get things going. So if you realize there's an impact, it's reducing time, you need to highlight that, not just for yourselves, but also for your stakeholders as well, to make sure that you're doing the right thing, to prove that you are moving in the right direction. Second part here is on the sort of architecture and design side of things. So urban planners and designers, they usually tend to face big challenges, identifying patterns that kind of scale up because of the size of projects that you work on, also aligning with the ESG goals, but also managing data in a big, inclusive, livable type of space. Again, with what we're trying to do in this kind of specific pillar is basically making sure that location intelligence works better for things such as site selection, impact analysis, and design decisions. And this is kind of provides things like such as 2D and 3D and time-aware maps to improve collaboration between different actors that kind of play in that space, from architects to engineers to designers and people that kind of really don't have a lot to do with GIS. So in terms of capabilities and things like we've spoken a little bit about flood analysis, and this could be not just in the built environment, but this also happens in the big wild environment, where before you even touch the building blocks that you're going into. There's a new tool called the Flood Simulation tool in ArcGIS Pro that kind of developed specifically for flood simulations, and that's inside the inside Pro that you can use. It uses digital terrain models and embedded physical models in order to simulate where rainfall might go. Common problem in this region a lot: when rain falls, it really falls here. And the maps we create are, again, gradually increasing, becoming very closer to actual reality and how things are on the ground. Our maps are becoming, again, more realistic as well, to kind of portray that and reflect that, but they're also true image of reality and are able to describe the relationships as well between buildings, between utilities, roads, road assets, and so forth. So this is what we call usually a digital twin. It's reality mapping helps us build that twin. It helps us to kind of create 3D meshes and things like this is the city of Stuttgart in Germany, for instance, which this embedding that reality and creating that reality offers the foundation to everything that's going to go on top of it, all the overlays, all the layers, the road transportation layers, and so forth. But also, this kind of can go into other things like we see here, integrating BIM models, for example, like of a train station, where you can embed the BIM model, move it into GIS. When you get in there, you can easily run analysis that ingests BIM data, but also leverages GIS analytical tools in order to analyze that, not just visualize it in 3D, but also analyze it in a very profound manner. Obviously, things like, again, flood analysis, coming back to the picture, what if it rains? How good is my BIM model in space? And this is when GIS plays that role. It kind of helps you understand the impact on that. And it helps you as well identify things in your environment, count number of trees, count vehicles, things like that, which is very, very fundamental to why we kind of enhance our tools to embed things like GeoAI and deep learning to capture these elements. But obviously, the way you experience GIS information as well also has changed. So now, we kind of use gaming engines and everything. Everything when it comes to people who are not really GIS people. Us as GIS practitioners, sometimes we think like, well, do we need this to visualize it in reality? But other people that are looking at our stakeholders that you want to show GIS data, they want to look at ArcGIS Pro. What they want to look at are things that are fancy like that, things that are a bit more real, and they can connect to and run simulations based on and play around with in order to have that in a better visual that you can look into. And then looking even into BIM data that goes into GIS and transforming that into the GIS, and then putting that into using gaming engine looking into a 3D model helps you not just visualize those things, but even the analysis and the outputs of analysis that you run could be visualized on that gaming engine, depending on whatever you want to show. So, a few examples here in this space is an example in California, and that's basically done by one of our partners, House of Levine in Canada. So basically, in California, they basically all cities and countries are legally required to plan for housing through a housing element, which is basically a housing planning permission that they request for, and this kind of helps. This is updated as part of the general plan and informed by the regional housing needs assessment, or the RHNA. Basically, what our partner here has done, they've built this. So they have there's a product we have, which is ArcGIS Urban. You heard of it in another session. They have the specialty to kind of work with ArcGIS Urban, and what they've done is basically helped identify suitable sites and areas where test developments and the growth of the city, where the urban rather than urban sprawl happening randomly, they can plan it in a way that's based on information, based on GIS data, that again has metrics and has numbers in it. This GIS-driven approach has been delivered across 20 plus ArcGIS urban implementations and multiple regional agencies, and this obviously provides transparency across to kind of show the different elements of the sites that you're building, but also you can create reports automatically. So these reports are created automatically to assess the whatever you're proposing to build. An example here from Kuwait is South Sabah Al Ahmed city, and again, this is one of our partners, fosters and partners who kind of work in the urban planning side of things, and they basically been handed the city to plan and design. So it's a new city that's meant to host 280,000 residents, covering 24 square miles, with again sustainability and human scale living at its core. The key challenges there were understanding the context of the city at scale, developing a coherent design, and integrating multidisciplinary workflows from different departments across architecture, landscape, transport, and social planning. They've used City Engine, which is another tool that falls under ArcGIS Urban Suite, And what City Engine does is helps them do advanced analytics on the way they design the city, the way they calculate shade analysis, where people are going to go out for a walk in the morning and be shaded most of the time, where airflow analysis are taken into consideration as well within the design. Green spaces are not just sporadic; they're not just centralized in certain areas. They're distributed in a way to suit the development as it's being designed. All that again, since you're going back to ArcGIS Urban and how it works, is putting that into numbers. You're not just designing and then, well, it looks nice, let's build it. It doesn't work like that. You have to have numbers, which is this is why we have GIS. You have numbers in order to qualify those elements. Sweden here, an example. Cities in Sweden and property developers usually they build big parts. They kind of master developers, and obviously it involves a lot of strategic planning and real estate. The departments working in parallel together in order to make sure that planning and all the buildings and designs are done coherently together. So the early focus was on parametric massing models, managing multiple design iterations and making sure that those are all done coherently together in one GIS. Obviously, the GFA or the gross floor area is calculated as you go constantly as a big metric to kind of make sure that, well, we're generating that much living space for people as we go. And obviously, integrating GIS and BIM kind of plays a big part in that, in assessing those spaces. Globally, again, taking that to a next level and adding the kind of generative AI to it. So this is an interface done by again our partner Hassel Levine. They kind of they call it Euclid HL. A few partners are starting doing that trend as well, following that trend. And the idea is building a planning tool where me as a citizen, I want to build a fence, I want to build an extension to my house. I can't go through this whole planning guidelines. I cannot Google stuff. I cannot search for stuff. What happens is they went to city departments. They ingest that big documentation, and then what they do is they try to tell people to kind of type in the questions, ask the questions, ask it in a chat way to see if they can build the stuff, and the machine reads through the documents, provides evidence, and replies to them. The third part I want to talk to is engineering and consulting, and that is a practice where we've spoken about BIM and GIS, but it's the not just the planning side of things, but it's also the collaborative environment where distributed teams come together for digital delivery, and we've spoken about BIM and GIS integration. I'm sure you've heard about that a lot by now. But this is a city of Nottingham council city. What they've done is they've used an ArcGIS Urban for planning as well. But what they're doing here is that they're superimposing different scenarios. They see they calculate shade analysis. They calculate the number of residents that could live in that location, in that building. They superimpose different elements as they wish, and as part of that, as part of all the proposals that come from different people and different developers to kind of build within their city, they start calculating those metrics, and automatically they have the metrics. A person goes in and verifies or disapproves certain things and returns it with comments. All that's a long list of analysis that goes through, and obviously that goes into things like dashboards that kind of enable you to see these different developments afterwards and see where which ones have been approved, which ones haven't, and the timelines on them. Have they started development? Have they started construction or not, and so forth. So that's the sort of a summary of it. And obviously, for one major thing that they've done there is using that is that in every 2 English pounds that they've spent in this investment of this infrastructure, they've saved one pound. So I'm going to move on now to the UAE and Dubai Smart Cities initiatives, where they have a big 2040 master plan, Expo 2020 as well, area in Dubai, where they kind of build built an airport, they built a big master plan with sustainability goals and other elements. But the idea here is that they wanted to plan all that in real time with city stakeholders at place, and they had to. There's a lot of integration with GIS and BIM in order to kind of make that a reality, but also make sure that all the zoning elements are being taken into consideration, shift in zones and increase in areas where city center and where the city center increases, where the shops and the stores that engage people and the public increase as they go. Now, there's a very beautiful example here of a very explicit and big GIS implementation that I want to show here, done by Room1 MENA in the city, and I would like to invite Mr. Bandar, who manages GIS and a lot of infrastructural stuff in there, to kind of give us a little bit of a brief of that.
Yeah, thank you, Dr. Adel. Thank you, Mohandas Hisham. I won't take a long time from the session. Just I want to focus more on that integration between BIM model and GIS platform. We have done the automation of the converting BIM models via ETL tools that convert automatically the BIM models from the Revit source files to the GIS platform. At the same time, we have been able to, by piloting our own drones in Room1 MENA and integrating that as well with the BIM models. So our team, for the first time, were able to see or to compare between the site existing, which came from the drone images, and versus the design that is coming from the BIM models. Maybe that was the greatest achievement and integration between the drone imageries and BIM in GIS platform have been done in GIS. And thank you.
Thank you, Mr. Bandar. It's obviously amazing work in the sense that it's a comprehensive portal. It's got a lot of information. It literally brings all the departments together in a very and obviously building. I mean, this doesn't make it pay justice, because the portal kind of has so many applications and things that serve different departments, which is also even ever expanding beyond just being a GIS. Another example here is Spark City. Hisham is going to walk us through this one.
Okay, one more example in the Kingdom of Saudi Arabia is the Spark, or King Salman Energy Park. It's one more example of a specific usage of cities. This is an industrial city, and they have made use of the GIS for the navigation purposes. So as we all know that in construction projects we have multiple resources, multiple elements in different places across the construction site, and they have utilized the power of ArcGIS mobile apps. This is no-code applications, so they can make use of it to find what they are looking for in an easy way. In addition to this, of course, as we've mentioned in other previous success stories, it's the BIM and GIS integration. So who is taking care of this type of integration is the engineering department within a Spark, and they made a very good use of as well ArcGIS GeoBIM. That, as we can see here, that can help you to have a dual view of both the BIM environment and the GIS environment. So BIM and GIS, in this case, you're not replacing each other. We are completing each other. So you have access to the very detailed information from the BIM side, and we can call it like eagle eye view, and the surrounding area, the exterior shell of the buildings on the GIS side. And in this way, you can go for the cherry on the top, which is the dashboard that can help you to, and this is actually what they have used for, to do the dashboard for monitoring of the progress of the project. One more example in Saudi Arabia, which is the Diraya Gate company, and actually they have made a very good use of other piece of technology from Esri, which is ArcGIS Urban, to manage over to plan for for management over 600 historical properties. And they have as we can see here, and actually this platform is for public, so you can Google it and you can find it. So they made a very good use of the storytelling, map-centric storytelling. So you can use the story maps, their story map, to make like a visual tour to the different historical places within Diriyah.
Okay. All right. So last pillar is the construction management element, and we probably spoke about this a little bit in a previous session if you were in it. But basically, the idea here is again making sure that we bring all these kind of timelines, the project management information, the milestones that we have in it, all the safety risks, and all the kind of elements that to do with site in one place with the GIS in order to kind of again shoot out different applications for different people that manage safety, other people who kind of are in the construction side of things, people who want to monitor where our assets are and the asset management element and so forth. So this is the idea is kind of bring in that construction site into one place. And obviously things like field and reality capture is one is quite an important one to kind of show. This is an example of the Red Rocks Amphitheater in Colorado in the US. And it's captured by drone and processed in just hours into a very high quality digital terrain model. The ortho and true ortho imagery are GIS ready, used right away. You can take that right from the scan into GIS and start using it straight away. It enables obviously that you create kind of 3D meshes, 3D data very quickly. You create this element. It looks very real. And embedded, and not just looks real, but also is analyzable very easily. Obviously, this kind of brings us to the idea of kind of bringing all these parts together. So the reality mapping element, field mobility with all the field apps, Survey 1 to 3, and quick capture and so forth, and the real-time element with the likes of ArcGIS Velocity, product you probably heard about a lot these days. That kind of streamlines, that streams all these kind of things very quickly. But then another thing is also all these kind of technologies that kind of do different things. The technologies are GIS doesn't work in a silo. A project has so many technologies, so many elements, so many organizations that work together in order to work with BIM data, do the project management side of things, do facility management, do asset management, and so forth. And the idea is catering and kind of opening those plugins to kind of connect to all those environments, not just on a technology side of things, but making sure that they actually serve a purpose. They serve the surveyor while he's doing his job. They serve the planner while doing his job, and so forth. An example here I want to show is of Qatar in Lusail City Development, where you have is developed. It's obviously been a city that has been developed for the FIFA World Cup 2022. It used GIS and BIM together to manage city-scale infrastructure delivery under extreme time and coordination pressure. It enabled 4D progress tracking, so 4D as in the fourth dimension being time, traffic and logistics optimization, and BIM and GIS-based asset management. Obviously, this makes sure that everyone under those tight timelines kind of coordinates and works in the right way. There are apps that have been developed out of the GIS very quickly, and then they've been thrown away afterwards because they've built all the infrastructure and stuff, and they got rid of these apps. They don't need them anymore. But they built other apps because the data is still there to kind of serve the maintenance and running of the entire city. So it's been a great this has been a great thing to measure. And obviously they put metrics there of 15% fewer construction delays with real-time GIS tracking because they knew where things are at the right time. Now, moving on to our local one here for Saudi Arabia is Jeddah Central Development Company, and we've got Engineer Ahmed.
Thank you, Dr. Adel. I don't know if my voice is clear for you. Thank you, Dr. Adel. Thank you, Engineer Hisham. So in Jeddah Central Development Company, we did something could be easy, but we find a lot of challenges. So we just connect the people to each other. Just it. We have the planning team Primavera, and we have the payment and SAP team in another side. We have BIM team in a different side also. All of them, they are not aware of what others doing in their lives. So what we did, we have the context, we have the special context, the special language. So we define them to each others and we connect them to each others. So we present it to the decision maker, because the decision maker, he feel like looks like he's blind, he don't know what's going on. And if he would like to get any report about the progress of the projects, we have many projects running at the same time. He used to expect that within 1 week or 2 weeks he gonna get back the report and he will put his comments, and the team will work on it and then send it back to him. It's a dilemma. It takes long time, but all these things together, we bring him a magical tool. Hey, we connect the old people to each other. It's not easy journey, and it's very, very struggling. But the success deserve to go through this challenge, and to have a strong belief that you're gonna success and you're gonna bring something talented. It's only one that can help people and sit in the background. Hey guys, I didn't do anything. I'm just helping you. I'm serving you as a GIS. I'm not looking for exposure, but I have something unique and can help you to speak to each other. So this is what we did. Help the BIM team to understand the structure of Primavera and the structure of SAP team, to connecting all things together. And then finally we bring the satellite image and 360 images. Daily 360 images come from the site, also associated with time and the location, so the decision maker can see the full picture. Okay, thank you.
Thank you. Okay, thank you, Engineer Ahmed. Thank you, Engineer Bandar, for sharing your success stories with us. Actually, your work usually, and as you know, it's always an inspiration for the other organizations, especially when it comes to AEC implementation, AEC workflows in the Kingdom, and of course today we are talking on a regional scope as well. As we can see here is a snapshot of the current Saudi market, and you can notice the size of the market right now, especially when it comes to the AEC. So the AEC market right now, the total value is over than like more than $900 billion. This is the total work awarded to date, and we can see here many projects. We're talking about Ro'al Medina, we're talking about GCDC, we're talking about Red Sea, and as we have witnessed today, that most of the, or maybe all of the current the project that we were seeing, we're witnessing, they are a current GIS user. So this takes us to the next step, which is, now we know that there is a huge development when it comes to the AEC in the Kingdom of Saudi Arabia as part of the Vision 2030. But are we ready in Saudi Arabia for such a thing? So maybe you have heard about the geospatial knowledge infrastructure. Geospatial knowledge infrastructure is a readiness index that gives us some insights about the capability of the country to develop different projects built on the geospatial technology. And this was released mid-year 2025, and Saudi Arabia had the 32 rank in 2022, and it jumped all the way to make it to the 9th place in the list in 2025, and the sixth in the rank in the G20 countries, and the first place in the Arab world. So when it comes to the geospatial knowledge infrastructure, we are here, we are ready, and we have witnessed today some very good implementations, excellent implementations locally. So we're moving actually behind these statistics to the digital twin implementation. And I think we're all in the AC sector are trying to achieve some sort of twinning to the real world assets, so it can help us to get better insights, better understanding of what's happening in the real world. And we can see here the digital twin market and how it's in some revolutionary way it increases from the year 2021, and it's expected to even jump more in the upcoming years. So we hear a lot about digital twin, and you might have heard about different definitions for the digital twin, but this is not 2026 should be. There's a lot of industry standards that are in the market right now, a lot of publications that define what's digital twin, what's the boundaries of digital twin, and what's the boundary line between what's digital twin and what's not a digital twin. So according to ISO, the digital twin is a digital representation of a target entity, what we call like a real world entity, and a data connection that enable convergence between the physical and the digital states. So the main idea of a digital twin, that you have a target entity and the digital entity, real world thing, digital world thing, and the main core of it is the data connection between the real world and the digital. And to make this happen, you need to build your digital twin on an appropriate rate of synchronization. So the data connection is the core of building a digital twin, and this is what we are trying to do, and we are trying to support the different digital twin initiatives through Esri technology. It should be driven by outcomes. It should be led by use cases, and it's as we will know, and as Jack mentioned today, it's powered by integration. So moving from ISO to another industry standard, which is the digital twin core capabilities. So the digital twin consortium, it's a non-profit organization, NGO, that is trying to standardize the digital twin implementation, digital twin concepts in the market, and they have came with this 6 core capabilities, starting trustworthiness, intelligence, data services, data management, management, user experience, and the integration. And under the umbrella of each capability of these 6 capabilities goes many other aspects. So they came with this periodic table, and as you can see here, according to the color, this is either data services, integration, intelligence, UX, or management, or trustworthiness. And we have made use of these industry standards to make sure that our technology is in the correct way with the industry standards. So there's no different definitions anymore for the digital twin. Once you need to implement one of these standards in your project, you will have the support of Esri technology when it comes to any pillar, any capability of these 6 capabilities, or any of their sub categories from the 6 to categories that we see. So ArcGIS enables digital twin, and it can be actually your digital twin. So as you know, and as we're talking since yesterday about integrating everything, we're not trying to replace systems. We're trying to bring everything in one common operating picture. Let's call it like that. So as Engineer Ahmed from GCD mentioned, that the process, the twinning process, it's a very tiring process. It's not easy, and I would like to emphasize here that it's an iterative process. It's not a one project thing. It has to be phase 1 and phase 2 and multiple phases. And as you can see here, the digital thread of the digital twin, it can be just to start with a descriptive twin, just a static representation, visual representation that just give a visualization for using reality mapping, maybe BIM model, maybe just a static model, and then you can build on it. So it's not a one-time thing. You need to put that in mind, and this is actually what ISO standards are telling as well, that it's an iterative process, and it takes time to achieve different maturity levels. The second maturity level, as we see in Esri, the informative one. And in the informative one, you start to put what ISO mentioned as appropriate rate of synchronization. So you start to put the connection here, whatever it's through IoT sensors or maybe mobile apps, and you start making use of the data that you have collected in the descriptive maturity level to extract different information from the data that you have collected. Then moving to the AI. So everyone talks now about AI and how we can make the best use of the data. So we have the data, the static data, and we have the updated data, the connected data that we keep receiving. So now we can use the AI to do forecasting, simulations, and other types of advanced analytics. And this can lead us to the comprehensive digital twin, which can help us to do some simulations to the outcomes that can be done if we're going to different scenarios. So we can do scenario planning. So without investing in the real world, so test and fail, you just can test using your digital twin to achieve the comprehensive level of digital twin. And of course, this all led to the highest maturity level, which is the autonomous digital twin. So this is how we see in Esri digital twin as ArcGIS as a geospatial operating system for achieving a digital twin. So it all starts with the data capture. So in ArcGIS you can bring in different data formats, whatever it's collected using laser scanners, drones. It can be satellite images, 3D meshes, or of course, as we have seen, BIM and CAD. All of the data sources will be in the foundational layer. Then we have the enterprise GIS, which has the different capabilities. So when we talk about simulation, it's not a digital twin, it's one of the capabilities. When we talk about visualization, 3D visualization, it's not a digital twin, it's one of the capabilities. So all of these capabilities comes within the ArcGIS or enterprise GIS. Then we move to integrating everything. So the system cannot be static. You need to keep updates to make sure of the state coverage and the state synchronization between the real world and the digital model. So we have many ways for integrations. It can be a system to system, as with Autodesk, with Trimble, if you have attended the last session, or through APIs. So today, if we are going to invent a new system, and tomorrow we need to integrate with it. So Esri have provided multiple APIs, so it helps you to integrate with whatever system as long as the other system is open for integration. And it's all led by the use cases and the industry, so you can, according to your needs, it can help you to be a planning twin, a design and construction, an operational twin, or an environmental twin. So I will try to be faster. I know that we went behind the schedule. So if you have a digital twin initiative in your organization, how can we support you? So this is the process that we follow to support different organizations to achieve their own digital twin initiatives. So it all starts with a discovery workshop. So we will have a round table, collect the requirements. Maybe if you're like GIS department, we can be connected with the business units, so you can support the different business units with the GIS. And after collecting all of this information, asking about the data formats, your plans, your goals, we move to the second step, which is the roadmap. And when it comes to the roadmap, it's some sort of targeted awareness sessions. So when we know more about your current organizational capabilities and your goals and vision, we can start to tailor some awareness sessions based on what we have collected in the discovery workshop. And moving from the roadmap, at some point you need to actually implement something, right? So it ends up with the final recommendation, with the tools, services, and the different ways that you can use to build your own digital twin initiative. So it all starts with defining the scope and objective, then collecting and building the what you're going to run later and operate. So one more thing about the Esri AEC community in Saudi Arabia. So it was announced back in the Esri Saudi User Conference back in 2023. And as part of it, we have released in 2024 the Esri Saudi Arabia AEC newsletter. You can find it on LinkedIn and on Esri Saudi Arabia page, and it covers different topics, like starting from international benchmarks to technology updates. And now we have reached around 10,000 subscribers, so you should follow it. I would recommend that. As well, we've had our first AEC day, or we can call it like AEC meeting for the AEC users in the Kingdom of Saudi Arabia, 2025, October 2025, and we're going to, inshallah, we're going to have the second one this year. So you will be invited. You're already invited. And to conclude, so if you're working now on your digital twin initiative, you should consider system thinking. So starting from your current capacity, like when it comes to people, then moving to the current organizational capabilities. What are the systems that you have now, and what are the systems that going to help you to build the whole vision of digital twin? And as we mentioned, everything starts with the data to have your complete vision of digital twin. That's it. Okay. Yeah. And yeah, please, Doctor.
So to conclude, thank you very much for listening. But again, in the apps, we'd appreciate very much if you send the feedback. Just one note on the AEC team, or the AEC group that we have again online on LinkedIn. Please feel free to join it if you're in Saudi Arabia or outside of Saudi Arabia. Just join it. We put so much material in it. We put so much updates, things that are related to it, events as well that are relevant to your market. It could be outside of Saudi Arabia as well. So even if you're outside of Saudi Arabia, it's very relevant still to you. And we encourage you massively to join it. Again, it's on LinkedIn. You also get announcements and things of that sort as well. But to conclude, thank you very much for being here in this session. I know it's the end of the day, so we're finally free to go back and
thank you for staying to this
chill out
extent.
for a bit. Thank you very much.
Thank you.
Thanks.